Do you know that each year, more than 50 million tons of pork are produced worldwide, with a significant portion transformed into bacon, the legendary companion of millions of breakfasts that captivates food lovers everywhere? The journey of these happiness-flavored bacon slices begins on vast farms with healthy pigs. After careful selection, the pork is processed through advanced systems to create the perfect final product. Today, join Agriculture Insight as we follow the journey of bacon through the world's most modern production lines, unveiling the secrets behind the flavor that has captured millions of hearts. Everything will be revealed in this video. On the global bacon race, the United States is the undisputed champion, producing over 2 million tons of bacon each year, accounting for nearly 50% of the world's supply. With such massive production, American bacon has become a national icon, appearing everywhere from breakfast tables and backyard barbecues to even bacon-flavored ice cream and pastries. Industry giants like Oscar Mayer and Hormel have helped turn bacon into a culinary legend of American culture, with 93% of households purchasing bacon regularly and many keeping at least one pack stocked in their fridge. Here's a fun fact. That crispy slice of bacon you enjoy every morning was once a prize in a marriage ceremony in England. At the Dunmow-Flitch trials, married couples who had lived harmoniously for over a year were publicly put on trial to prove that they had never regretted their union. The reward for enduring love? A giant slab of bacon. Bacon is not just a delicious treat, it's a timeless symbol of love and devotion. The journey of premium bacon begins on specialized farms, where pigs are closely monitored from birth. Each pig bred specifically for bacon production typically reaches a weight of around 110 kilograms in just 6 months, growing at a remarkable rate of up to 1.8 kilograms per day, nearly twice as fast as conventionally raised pigs. Their diet consists primarily of corn, wheat, and supplemented vitamins, designed to develop the ideal belly fat composition needed for high-quality bacon, with even fat marbling that delivers perfect crispness and rich flavor. Interestingly, some bacon-dedicated farms even incorporate beer into the pig's feed. Adding beer to their diet helps produce more evenly distributed and higher-quality fat, almost as if the pigs themselves are savoring a taste of flavor before transforming into bacon. After about 6 months of rearing, when the pigs have reached their ideal weight of approximately 110 kilograms, they begin their final journey from the farm to the processing plant. Before being loaded onto the transport trucks, the pigs are lightly washed using cleansing or disinfecting solutions. This step helps remove dirt, bacteria, and pathogens from the surface of their skin, reducing the risk of cross-contamination during transport and at the plant. Handlers use specialized tools such as mobile panels or soft paddles to gently guide the pigs. The walkway from the holding area to the transport truck is specially designed with a low incline, allowing the pigs to move easily without losing balance. High side barriers are typically installed along the walkway to limit external visibility and prevent the pigs from becoming distracted or startled by sudden noises, lights, or movement. Inside the truck, each tier is often lined with a layer of rice husks, sawdust, or other absorbent material. This not only provides better grip for the pigs, but also helps absorb moisture and maintain hygiene, making post-trip cleaning easier. The transport vehicles used are specially designed livestock trucks, usually multi-tiered to maximize space while maintaining ventilation and comfort. They are equipped with ventilation systems, shock absorption mechanisms, and often sensors to monitor interior conditions. These features help ensure that the pigs are transported in a safe, comfortable, and low-stress environment. The entire process from loading to transport requires not only technical expertise, but also strict adherence to animal welfare standards, hygiene protocols, and food safety regulations. Before entering the slaughtering process, pigs are taken to a designated resting area for a final health inspection. This stage is critical to ensure that the meat products, especially bacon, meet the highest food safety standards. Pigs are guided into a specialized washing area where their entire bodies are sprayed with clean, high-pressure water to remove dirt, mud, and waste residues from their skin. Following this preliminary rinse, they are lightly sprayed with a mild disinfectant solution, typically safe compounds such as lactic acid or low-concentration chlorine, to eliminate bacteria and pathogens present on the skin's surface. Before slaughter, pigs are anesthetized to ensure a painless process and to comply with animal welfare regulations. One of the most common methods is stunning with carbon dioxide, CO2. The pigs are guided into a sealed chamber where CO2 is introduced at a controlled concentration. Within several seconds, they lose consciousness completely. This method helps minimize stress, prevents unnecessary struggling or injury, and ensures the safety of both the animals and the workers involved. Immediately after stunning, the pigs are hung upside down and bled for about 3 to 5 minutes to allow maximum blood drainage. Once bleeding is complete, they are moved to the dehairing area. Here, the pigs are briefly immersed in a hot water tank at around 60 to 65 degrees Celsius to soften the hair follicles. They are then transferred to an automatic dehairing machine, where rotating rubber rollers remove hair and surface impurities. This step ensures the skin is clean and well prepared for the next stages of processing. The pigs are then hung on a sliding rail conveyor and moved to the singeing machine, where strong flames burn off the tiny remaining hairs and simultaneously sterilize the skin surface, ensuring hygiene standards are met before the evisceration process. After being cleaned, the pigs continue to the step of removing the anus. Then, they are moved to the area for evisceration and organ removal. Here, workers use a knife to make a longitudinal incision along the pig's abdomen, then gently pull out all the internal organs without rupturing the intestines, ensuring maximum hygiene. Once cleaned, the pigs are transferred to a high-capacity cutting machine. Here, they are precisely and quickly cut in half using sharp blades, ensuring that the meat remains intact and undamaged. The cutting machine uses advanced technology and automatic control, making the cutting process smooth and uniform, optimizing the use of raw materials. After being cut in half, the meat parts are transferred onto a conveyor belt. Here, they are further divided into specific parts, such as lean meat, fat, ribs, bones, and other sections. The sharp saw blades, combined with laser technology, make precise cuts, ensuring that each piece of meat is neatly separated without damaging its quality. The final product is of the highest quality while minimizing material loss. During the meat separation process, the pork belly, also known as the belly cut, is singled out as the primary ingredient for making bacon. An ideal pork belly typically features a balanced layering of fat and lean meat, creating a unique texture when fried or roasted. Crispy on the outside, juicy and tender on the inside. After being cut, the pork belly is inspected either manually or using sensor systems to ensure it meets the standards for thickness, fat-to-lean ratio, and size. Pieces that do not meet the requirements may be redirected to other processing lines, while the qualified cuts proceed to the curing stage. Once the pork belly is ready, the seasoning process begins, starting a journey to create the irresistible flavor of bacon. There are two common seasoning methods: dry curing and wet curing. In the dry curing method, the pork belly is evenly coated with a mixture of salt, sugar, pepper, garlic, and natural herbs, creating a perfect blend of flavors from the very first touch. Wet curing, more commonly used in industrial production, involves soaking the meat in a special brine solution that combines salt with spices such as sugar, pepper, garlic, and natural extracts, ensuring the meat absorbs the distinctive bacon flavor. To ensure the seasoning is evenly distributed, a specialized injection system with dozens of small stainless steel needles is used. The needles are carefully positioned across the meat surface, injecting the seasoning mixture precisely into each piece. This automated system works quickly and with pinpoint accuracy, allowing the seasoning to penetrate deeply from the surface to the core, creating a perfectly seasoned and uniform layer on each piece of bacon. This process not only ensures the flavor quality, but also optimizes the use of seasonings, resulting in a final product with rich, irresistible taste. Once the bacon has been meticulously seasoned, it enters the enchanting stage of smoking, a culinary wonder that transforms ordinary pork into an irresistible delicacy. The seasoned slabs are placed into smokehouses, where controlled heat and smoke from natural wood begin to work their magic. Depending on the type of wood used, oak, hickory, or even applewood, each imparts a distinct character, blending smoke and seasoning into a harmonious flavor signature unique to each batch of bacon. Smoking times can range from several hours to up to 24 hours, depending on the method and the desired flavor profile. Throughout the smoking process, the meat absorbs waves of aromatic smoke, with each breath of smoke adding another layer of rich, complex flavor to the meat. After smoking, the bacon slabs are removed from the smokehouse and pressed to create uniform thickness, preparing them for precise slicing. After pressing, the meat, now true bacon, is fragrant, tender, and richly imbued with smoky flavor. Yet its journey isn't quite finished. Before bacon can grace supermarket shelves or star in delicious breakfasts, it must undergo the critical and meticulous slicing phase. Large rectangular slabs of bacon are fed into automated slicing systems, equipped with razor-sharp stainless steel blades operating at high precision. These modern machines slice each piece consistently and attractively, with the ability to adjust the thickness of each bacon strip to meet exact standards. Some advanced slicers can process up to 60 packages of bacon per minute, equating to over 3,500 strips per hour, dramatically boosting production efficiency while minimizing error. Packaging is the final, yet equally important step in bacon production. After slicing, the bacon strips are neatly arranged and fed into modern packaging machines. Here, bacon is often vacuum sealed to remove air, helping to extend shelf life and prevent bacterial contamination. Depending on intended use, bacon can be packaged into convenient small packs for households or larger blocks for restaurants and supermarkets. The packaging is robust and clearly labeled with origin and expiration dates, ensuring that each slice of bacon reaches the consumer fresh, safe, and flavorful. Bacon is not just food. It has become a vibrant cultural icon in modern life. From traditional American breakfasts to bold culinary creations like bacon-stuffed donuts, bacon-flavored ice cream, and even bacon-infused cocktails, this smoky slice has transcended its role as a mere side dish to become a centerpiece of popular culinary culture. With its rich flavor, enticing aroma, and incredible versatility, bacon represents simple pleasures, comfort, and a playful hint of rebellion, key ingredients that define the spirit of modern Western food culture. For many, bacon is intertwined with memories, emotions, and connection, from family meals to spontaneous parties. It is a small but mighty joy, a humble strip of meat that captures the very soul of a free-spirited and creative culinary tradition. Bacon is born from a meticulous process, capturing both rich flavor and expert craftsmanship. But this is just the beginning of many other fascinating stories in the world of food. Pizza, a small circle, yet a powerful symbol of the entire fast food industry. It's often called an addiction flavored with oregano and tomato sauce, capturing the hearts and stomachs of billions across the globe every single day. You can find a $5 pizza baked in a brick oven on a Naples street corner, or order a $12,000 version at a luxury restaurant in New York, topped with caviar, truffles, and gold leaf. And while a pizza can be sliced into 8 even pieces, the battle for each slice of the market is far from evenly split. For decades, Pizza Hut reigned supreme with its classic dine-in restaurants, family-friendly ambiance, and broad menu. But since 2018, Domino's flipped the script, becoming the largest pizza chain in the US by revenue, thanks to its massive automation systems and highly optimized logistics network. The race is so fierce that even McDonald's, the global fast food titan, once tried to enter the pizza market back in the 1980s. But eventually, even McDonald's had to retreat quietly, unable to keep up with Domino's. So yes, pizza is more than just food. It's a global culinary icon where creativity, technology, and business collide on a single crispy crust. Which pizza is your true love? Drop a comment below and share it with me. And right now, join me on a breathtaking journey through endless wheat fields, the very beginning of those golden, crispy crusts that make the world fall in love with pizza. In June, across the states of Kansas, the wheat capitals of the United States, endless fields turn a brilliant shade of gold under the summer sun. It's a familiar signal. Harvest season has begun. Right then, the massive combine harvesters begin to roll. Each one stands nearly 3 meters tall, stretches over 10 meters long, so massive that anyone standing beside it looks completely dwarfed by the steel giant. Small in size perhaps, but still in full command of the entire harvest. At the front, a sharp cutting blade glides just above the ground, neatly drawing whole stalks into the machine. The leftover straw is returned to the field like a natural mulch, while the clean kernels are collected into an onboard storage tank. Each modern harvester can collect over 90 tons of wheat per hour, an astonishing figure, equal to the labor of hundreds of workers operating non-stop, leaving behind the bulky, complicated machines of the past that once dominated the fields. These days, farmers no longer have to bend over with sickles to harvest each stalk by hand. But that doesn't mean they have it easy. The fields today are more expansive than ever, stretching endlessly to the horizon, so vast that even a bird in flight might never reach the end. To make it more challenging, harvesting can only happen in the early morning or late afternoon, when moisture levels are just right to avoid cracked or damaged grains. That's why lunch often means a cold meal eaten in a hurry under the shade of a harvester, chewing between rows, eyes still watching the field bathed in golden light. Out here, every minute counts, and true rest becomes a rare luxury during harvest season. Then it's right back to the harvest. Grain tank is full, the wheat is unloaded directly into large trucks driving alongside the field, or a specialized truck drives alongside the harvester, receiving a steady stream of wheat pouring from the unloading pipe, all happening seamlessly, without the machine stopping for even a second. This synchronized and precise process helps optimize time, maintain ideal freshness and dryness, and preserve the grain's quality, minimizing post-harvest losses to the greatest extent. After being harvested from vast wheat fields, the grain is transported to a grain storage facility. Here, the wheat is unloaded into underground receiving pits. These are steel-reinforced pits, built directly beneath the receiving area of the facility. From these pits, the wheat is moved by conveyor belts or bucket elevators into large silos, towering cylindrical storage tanks made of steel or concrete. Inside the silos, the wheat is stored under strictly controlled conditions for humidity, temperature, and ventilation. Inside these seemingly empty metal ducts, tons of wheat grains are silently moving, weaving through every bend and corner, making their way to specific areas such as cleaning machines and moisture conditioning units within the factory. After being thoroughly cleaned and resting inside massive silos, wheat begins its next journey, heading to the flour mill. But instead of walking or hopping on a train, the wheat slides through enclosed pipes and industrial chutes. At the end of the slide, tons of golden wheat grains come rushing down into enormous trucks, each capable of carrying 25 to 30 tons, roughly the weight of 5 full-grown elephants. But don't think they can just hit the road right away. Before leaving the site, each truck must pass through an electronic weigh station, ensuring the load is within legal limits and recording the exact weight down to the last kilogram. This strict monitoring isn't just about avoiding overloaded trucks. It's also essential for inventory management and traceability. In the food processing industry, every grain of wheat must have its own identity papers. Inside the flour mill, after undergoing initial cleaning, the wheat grains are passed through an additional round of screening, this time much more meticulous. From the screening section, the grains are sent to a central distribution hopper system, where automated valves precisely control the flow of wheat into the next stages of processing. However, before they can be milled, the grains must go through large tempering tanks. The wheat is lightly moistened and left to rest for 12 to 24 hours. This softens the outer bran layer, making it easier to separate during milling. Next comes what's often referred to as the heart of the factory, a long line of modern roller mills. In modern factories, a single production line can include 20 to 40 machines like this, each responsible for a different stage of grinding, from coarse to intermediate to fine milling. This setup maximizes both efficiency and flour quality, especially for specialty flours like pizza flour. Each pair of steel rollers spins steadily, crushing the wheat kernels and gently separating the bran, the germ, and the bright white endosperm inside. It's this endosperm, rich in starch and protein, that becomes the smooth white flour, the very foundation of a perfect pizza crust. After milling, the flour isn't ready for packaging just yet. You think those machines bouncing up and down like they've had one too many espressos? They're not dancing for fun. They're plan sifters, the unsung heroes making sure your pizza flour is smoother than your best pickup line. A large rectangular machine suspended by flexible rods, containing multiple layers of fine mesh screens. The machine gently vibrates, allowing the flour to be sorted by size with micron-level precision. Flour that meets the standard moves forward, while coarser particles are sent back for regrinding. This is the final and most critical sifting stage, ensuring pizza flour comes out consistently fine and high quality. Because with pizza, even the tiniest inconsistency can throw off the perfect crust. Next, the fine flour is transported through a high-pressure pneumatic system. Think of it as a high-speed expressway just for flour. It's carried to a cyclone separator, where centrifugal force separates the flour from the airstream, allowing for clean, dust-free, and lossless recovery. And those tangled stainless steel pipes that look like a maze? They're part of the system that delivers flour to the blending station. Here, the fine flour is given its final adjustments. Depending on the end product, enzymes, malt flour, or B vitamins may be added. Finally, after passing the last quality check for fineness and fluffiness, the flour is sent to the automated packing area. Here, every stream of fine flour is precisely weighed, filled into pre-labeled bags, and tightly sealed to preserve its freshness. Each bag typically weighs around 25 kilograms, just the right size for bakeries and food factories. Robotic arms carefully lift each bag of flour one by one, smoothly rotating and placing them neatly onto waiting pallets. The finished flour bags are then neatly stacked in climate-controlled storage, where both temperature and humidity are carefully monitored. And just like that, every pizza crust begins with a journey this meticulous. Right now, let's step into the pizza production factory, where all the anticipation truly begins. But before those golden, crispy pizza crusts hit the oven, let's take a quick detour to meet its flour-based cousin, the croissant, a pastry that also begins with the same soft white flour. The process begins with the most essential base ingredient, flour. First, a large amount of fine white flour is poured into the industrial mixing bowl, the very backbone of every croissant dough. Next comes the yeast, usually in fresh or compressed form. It's what brings the dough to life, giving the croissant its airy rise and soft texture. Then comes the cold water. Here's a little secret. To keep the dough cool and stable, especially during high-speed mixing, ice water or chilled water is often used. This helps prevent the butter from melting too soon later in the process and ensures the dough stays firm and ready for lamination. All of it goes into a massive industrial mixer, where powerful mixing arms knead the dough into a smooth, elastic mass, ready for the next act, the art of lamination. After the mixing and resting process is complete, the croissant dough moves on to a particularly crucial stage, lamination and shaping. Here the dough passes through an automated rolling system, where it's flattened and stretched into long, even sheets, as smooth and pale as ivory silk. Each sheet isn't just plain dough, it's a precise fusion of dough and butter, folded, rolled, and rested repeatedly in a process known as lamination. After every fold, the machine gently sprinkles a thin layer of flour over the surface, not only to prevent sticking, but also to ensure each layer stacks cleanly and distinctly. The alignment laser acts like the eyes of the production line, precisely positioning the dough along the programmed axis. This allows the rolling machine to shape each piece smoothly and uniformly. It's especially critical for croissants because even a slight misalignment can ruin the signature layered structure of the pastry. After being rolled into thin, the croissant dough is sent into a cutting machine that slices it into triangular shapes. However, along the outer edges of the dough sheet, excess strips often appear uneven, jagged, or fall outside the required dimensions. At this point, the automatic edge trimming system takes over. Additional side blades remove the unwanted edges, leaving each dough piece clean-cut, symmetrical, and easy to roll. After the croissant dough is cut, it moves on to the spreading stage, where each piece is gently separated and evenly arranged on the conveyor belt. Depending on the type of croissant being produced, some are rolled immediately, while others are upgraded with rich almond filling, fragrant chocolate, or savory ham and cheese. Then, intelligent rollers gently roll each piece from base to tip, creating the signature crescent shape we all recognize. The finished croissants look perfectly uniform, glossy, and irresistibly appealing, ready to head into the oven. The trays of dough now enter massive industrial ovens, where hundreds of croissants begin their spectacular transformation. At a temperature of around 107 to 190 degrees Celsius, the buttery layers slowly rise and expand. Each layer turns crisp and the edges curl upward with proud elegance. In just 15 to 20 minutes, you'll witness something close to magical. From simple rolled dough, the croissants emerge golden brown, light and airy. Then the croissants are transferred to the automated packaging area. Here they are sorted and neatly placed into bags. Each package is vacuum sealed and ready to be shipped to bakeries, supermarkets, and cafes around the world. And now comes the moment we've all been waiting for. Don't forget, we're still on a journey to create the perfect pizza. It all begins with the crispy, chewy crust, the foundation that can make or break a great pizza. Once the dough has rested long enough, it's divided into long strips and passed through rollers. Next, the dough enters the shaping and cutting stage, where circular, square, or oval cutters form each base precisely. Have you ever noticed those tiny little holes on a pizza crust? They look like someone gently poked the dough with a fork. Those holes actually help steam escape during baking, preventing the crust from puffing up or cracking. And this is where the real differences begin to show. If the croissant is a symphony of butter and layers, pizza is a playground of tomato sauce, cheese, and whatever flavors your heart desires. At this stage, the pizza crust is partially baked to set its structure, Lightly dry the surface and prevent the tomato sauce from soaking into the dough later on. Next, the tomato sauce is gently spread across the crust. This special sauce is made from ripe, juicy tomatoes blended with garlic, oregano, basil, and a touch of olive oil, creating a rich, slightly sweet and aromatic flavor that defines a classic pizza. The automatic cheese applicator operates with absolute precision. It uses fresh mozzarella, a cheese famous for its smooth melt, glossy finish, and rich texture that stays soft without releasing excess moisture. This is the secret weapon behind the irresistible appeal of every pizza. The amount of cheese is pre-measured according to specific recipes, depending on the pizza type, from classic to premium, to ensure the perfect stretch and deliciously melty richness when baked. Next, toppings like pepperoni, sausage, or bacon are automatically distributed over the freshly layered cheese. Slices of bright red pepperoni are neatly arranged, creating a visually appealing pattern and ensuring every bite is packed with rich, savory flavor. Before packaging, each pizza takes a quick trip through a gentle heating tunnel, like a mini spa session where the cheese melts just enough to hug the toppings tightly. This helps lock everything in place so nothing slides around during transport. Even better, the heat gives the surface a light sterilization, keeping the pizza fresh and safe for longer. After exiting the heating tunnel, the pizzas are moved to the packaging area. First, each pizza is tightly wrapped in plastic film to preserve freshness and maintain its shape during transport. Then, it's placed into a tray or box, labeled with product information and expiry date, and sent to cold storage for preservation before distribution. After that, the pizzas are transported to supermarkets, convenience stores, and distribution centers across the country. They are kept in consistently cold conditions throughout the journey to preserve their quality. And just like that, each fresh and delicious pizza is ready to become part of the daily meals of millions of families. Imagine standing in the middle of vast, lush cucumber fields, bathed in sunlight, stretching endlessly to the horizon. Welcome to China, the king of agriculture, where over 77 million tons of cucumbers are harvested every year, accounting for up to 80% of global production. However, production alone is not everything. When it comes to pickles, the United States is the true king, with renowned brands like Vlasic, Mount Olive, Clausen, and a pickled cucumber industry worth billions of dollars, closely tied to the fast food boom. With their sharp, salty flavor and irresistible crunch, stand out as a refreshing contrast to other pickled products like brined olives or pickled beets, offering a distinctive tanginess along with the added benefits of probiotics that help support digestion and improve gut health. Among over 100 varieties of cucumbers, only a few have thin skin, few seeds, are crunchy, and absorb flavor well, making them suitable for pickling. However, even within that group, only the high-quality 5 to 8 centimeters gherkin cucumbers, out of millions, are selected to create the tangy, crunchy pickles that are the soul of millions of jars worldwide. This explains why gherkin pickles, with a history spanning over 4,000 years, continue to exist and have become the golden spice, beloved globally and playing an essential role in the food industry. And every legend has a starting point somewhere. For pickles, the iconic sidekick that has won over millions of food lovers around the world, that journey begins in the sun-drenched, green cucumber fields. From May to July each year, the cucumber fields become more vibrant than ever as the harvest season officially begins. On the vast fields stretching endlessly, modern machines, large, precise, and powerful, have become the extended arms of farmers during the busy season. As the machine moves along each row of cucumbers, the harvesting head functions like a giant comb, brushing through each stem and guiding the vines into the machine. Inside, an automatic sorting system removes unnecessary leaves and stems while only keeping the cucumbers that meet the standards and transferring them to the conveyor belt behind. Unlike the modern potato harvesting machines from Grimm or John Deere, which are designed to dig up soil and separate potatoes from the ground with a capacity of up to 20 tons per hour, cucumber harvesting machines are built to be lighter and more precise, allowing them to harvest cucumbers without crushing the fruit, with a capacity of around 5 to 10 tons per hour. Traditional farming still yields stable cucumber harvests, but relies heavily on chemicals. In this context, organic farming, hydroponics, and greenhouses are gradually becoming the trend due to their ability to optimize yield, minimize negative environmental impacts, and address consumer concerns about pesticide residues and herbicides. Trailer, helping transport the cucumbers to the storage containers quickly and gently. Manual harvesting, although much less efficient compared to modern machines with a capacity up to 15 times higher, ensures the finesse and precision that machines cannot achieve. After harvesting, trucks quickly transport the cucumbers to processing factories within 2 to 4 hours, preserving their freshness, crispness, and texture before embarking on the next secret journey, becoming the tangy, crunchy pickles that captivate the world. At the pickle processing plant, trucks carrying millions of tons of fresh cucumbers line up one after another, entering the raw material intake area. In modern factories, cucumbers are introduced into a closed-loop washing system, with multiple stages designed to ensure food safety and high input quality. First, cucumbers from transport trucks are poured into large indoor water tanks. These tanks contain clean, continuously recirculating water, often treated with ozone, diluted chlorine, or light brine to eliminate surface contaminants. The gentle water flow helps rinse off soil and debris while moving the cucumbers toward the conveyor belt without causing any bruising. Next, the cucumber's palatalization, ensuring both hygiene and resource efficiency. This process doesn't fully eliminate pesticide or chemical residues, which may remain on the fruit's surface. Therefore, to ensure consumer health and safety, factories must conduct strict checks in addition to following farming standards. Modern methods like HPLC and MS detect pesticide residues with high accuracy, with residue levels ranging from 0.05 milligram to 5 milligrams per kilogram, depending on the pesticide and regulations. Now here's where it gets interesting. There are two popular methods, each with its own secret formula for making pickles: natural fermentation for traditional and premium lines, and quick vinegar pickling for industrial products. First, for the natural fermentation method, cucumbers are sorted and then placed into large fermentation tanks, often positioned outdoors to take advantage of the ambient temperature, providing ideal conditions for fermentation. This method not only saves energy, but also promotes the growth of beneficial bacteria, which in turn creates the characteristic sour taste and increases the probiotic content in the final product. Each tank is filled with brine solution, a mixture of salt water and spices like dill, garlic, pepper, bay leaves, and others, depending on the unique recipe of each brand. Difference in flavor and crunchiness between the natural fermentation method and the quick vinegar pickling method. Once the fermentation period is complete, the pickles are carefully removed from the brine tanks and immediately transferred to the processing line for final cleaning and inspection. At this stage, each pickle is thoroughly rinsed to remove any excess brine, spices, or sediment that may have settled during fermentation. After rinsing, the pickles pass through a visual inspection system, either by trained workers or automated optical scanners, to detect and remove any defective or damaged pieces. Next, the pickles are sorted by size and shape using precision mechanical graders, ensuring uniformity in the final product. They are then transferred into filling machines, where they are packed into jars or food-grade barrels. Before sealing, each container is filled with a final brine solution, either the original fermented brine or a fresh one, prepared under sterile conditions, to maintain flavor and preservation. Finally, the sealed jars undergo pasteurization in hot water baths or steam chambers, depending on the product type and shelf life requirements. This step helps to stabilize the pickles, ensuring food safety while retaining their natural crunch and probiotic benefits as much as possible. In contrast, the vinegar pickling method takes only a few hours, meeting the enormous demand with billions of jars produced worldwide each year, and a longer shelf life, all while being about 4 times cheaper than naturally fermented products for the same volume. And this is why this method is so effective. After being thoroughly washed and sorted, the cucumbers are placed directly into pre-sterilized glass jars or plastic containers to ensure absolute hygiene. Before the cucumbers are added, dry spices such as dill, garlic, mustard seeds, black pepper, and bay leaves are added to infuse natural fragrance. The cucumbers are then automatically divided into the glass jars. In addition to whole pickles, many products are also sliced into rounds, cut into chunks, or shaped in various ways, perfect for topping McDonald's or Burger King's burgers, or served with salads and sandwiches at chains like Subway and KFC. After the cucumbers are divided into jars, they are moved to the brine filling area, where the soaking solution is added to complete the flavor and preservation structure of the product. The key difference in this step lies in one essential ingredient: vinegar. For industrial pickle products, due to the lack of natural fermentation time, the brine solution must include vinegar, acetic acid, at a ratio of 5 to 10%, combined with salt, sugar, and other spices. While the natural fermentation method requires refrigeration to maintain freshness and is typically consumed within a few months, vinegar provides an immediate sour taste. It also acts as a natural preservative, allowing the product to be stored at room temperature for up to a year or longer, making it more convenient for large-scale distribution in the global industry. For industrial pickle lines, this is also the beginning of the short fermentation process, which is strictly controlled for temperature and humidity, ensuring the product achieves a consistent flavor and standard crunchiness. So is naturally fermented pickled cucumber or quick vinegar pickled cucumber your idea of the perfect jar of pickles? The next step is pasteurization. Typically, the jars of pickles are placed in a continuous pasteurizer or high-pressure retort, where they are heated to a temperature between 80 degrees Celsius and 100 degrees Celsius for 10 to 30 minutes. After leaving the heat chamber, the product is rapidly cooled by passing through a cold water spray system, combined with high-powered fans placed along the conveyor belt, which helps quickly lower the temperature and prevent overheating or changes in the pickle's texture. Most naturally fermented pickles don't require pasteurization, as the fermentation process creates an acidic environment that inhibits harmful bacteria and preserves beneficial probiotics. Finally, the jars of pickles are placed on a conveyor belt and pass through an automatic labeling system. Each label clearly displays the product name, ingredients, production date, and expiration date. This step ensures that all jars have consistent, accurate, and compliant information for distribution. Pickles not only play a vital role in the global economy, generating billions of dollars in revenue each year, but also serve as a cultural bridge, connecting diverse culinary traditions and bringing the distinctive sour flavor of 4,000 years of history to kitchens around the world. Imagine standing in the middle of a sun-drenched cornfield, where towering stalks sway proudly in the breeze. Welcome to Minnesota, Washington, and Wisconsin, USA, the sweet corn capital of the world. Every year, the United States not only harvests up to 3 million tons of sweet corn, but also dominates global field corn production with a staggering 380 million tons, grown across farmland as vast as the entire country of Germany. America's scale is so overwhelming that even if you combine the entire corn harvests of China and Brazil, it would barely keep pace with the US. Yet beyond the staggering numbers, corn has always been a quiet part of our everyday lives. We grew up nourished by sweet cereal at sunrise and golden canned corn come supper time. Simple comforts that fed not just our bodies, but the tender memories of a simpler world. Compared to potatoes, corn is nearly twice as affordable and yet richer in nutrition, boasting higher levels of protein, fiber, and vitamin B9, along with lutein and zeaxanthin. However, with the emergence of genetically modified corn varieties in the late 20th century, a wave of concern spread among millions of consumers about the potential risks of cancer. That said, the majority of GMO corn today is field corn, used for livestock feed, ethanol production, and industrial products. While sweet corn, the type we typically enjoy fresh, canned, or frozen, is rarely genetically modified. This has been a common misconception that has persisted for decades. Setting controversies aside, the journey of sweet corn has never truly ended. Every July, as the corn silks dry up and the fields turn golden, it signals the arrival of a bustling harvest season. And it's also when the farmers' daughters, along with their mighty machines, gear up for the harvest. In only the quality ears of corn and send them up a conveyor belt into a holding tank or directly into a transport truck. Meanwhile, the leftover stalks, husks, and leaves are blown out the back by a high-powered fan, falling onto the field to serve as natural mulch or raw material for composting. While combine harvesters for field corn focus on shelling kernels efficiently for industrial use, sweet corn harvesters prioritize handling each ear gently, ensuring the kernels remain plump, juicy, and visually perfect for fresh markets and premium processing. A high-capacity harvester can process up to 15 to 20 tons of corn per hour, equivalent to the output of over 100 manual laborers working non-stop. Yet, as modern machines gradually replace human hands, the question of whether we should return to the fields, to sow and tend the land ourselves instead of relying entirely on machines and chemicals, remains open, touching on the preservation of original flavors and the enduring life of our planet. Small pieces and blow the chopped material into large trailers. Afterward, the chopped corn is packed tightly into silos or bunkers, where it undergoes a natural fermentation process to become silage, a nutrient-rich feed that helps nourish hundreds of thousands of happy cattle across vast farms. Although technology has advanced significantly, it is the diligent hands of workers that still bring a level of superior quality that machines cannot replicate. Manual harvesting, although far less efficient than modern machines, operating up to 15 times faster, preserves the natural integrity and quality of each ear, ensuring they reach the next stage in perfect condition. With the fields harvested and the golden kernels carefully collected, the journey now moves from the sunlit farms to state-of-the-art factories, where sweet corn is about to be transformed into the delicious products we enjoy every day. After harvesting, different types of corn embark on separate journeys depending on their final purpose. Some destined for sweet canned corn, others for delicious popcorn. Although both journeys start with corn kernels, the variety used for making popcorn, known as Zea maisa virta, is a distinct type of flint corn, quite different from sweet corn. At world-renowned popcorn factories like Orville Redenbacher's and the premium Dianon Gourmet popcorn, the process begins by preparing a rich blend of carefully selected ingredients. Although never officially disclosed, the secret formula behind perfect popcorn is believed to follow a mixture typically consisting of about 20% melted butter, 30% cooking oil, 45 to 50% sugar, and a small portion of other flavorings. Next, the dried corn kernels are fed into the popping chamber, where the machine heats up and builds pressure in preparation for the signature popping process. When the temperature reaches around 180 to 200 degrees Celsius, the kernels begin to burst simultaneously, releasing a sweet aroma and forming their light. In popcorn production, there are two distinct methods. Caramel popcorn is coated during the popping process itself, while other flavored varieties, such as cherry, cheese, or chocolate, are first popped plain and then coated with their respective flavors afterward. After being separated, the popcorn, whether plain or caramel coated, moves into a centrifugal cooling drum, where it is rapidly cooled and stabilized. This spinning process also removes broken kernels and excess caramel, ensuring that every finished popcorn piece is crisp, preparing each piece for the next stage of processing. After achieving its final color and flavor, the popcorn is transferred to the automated packaging area. Once packed, the finished products are neatly boxed, sealed, and moved to storage, ready to make their way to millions of sweet-toothed fans around the world. While popcorn brings bursts of flavor to lively movie nights, sweet canned corn holds the golden secrets behind the beloved cans enjoyed by billions. Secrets that we are about to uncover. After passing the inspection stage, the qualified ears of corn are sent directly to the automatic husking machine. This equipment uses a system of rollers and high-speed rotating blades to efficiently strip away the outer husks and silk in just a few seconds, without damaging the kernels inside. Thanks to sensors that precisely control cutting force and rotation speed, the machine ensures each ear of corn is handled gently yet thoroughly. Immediately afterward, the corn is passed through a high-pressure spray chamber, where clean water jets continuously from multiple directions. While high-pressure washing effectively removes dirt, debris, and surface residues from the corn, it does not completely eliminate pesticides that may have penetrated into the kernels. Therefore, strict control of farming practices and careful sourcing of raw materials are essential to ensure safe, high-quality products. For canned corn production, after husking, the ears are not packed whole, but are instead sent to a specialized kernel removal machine. This machine uses rotating blade shafts and compression rollers to quickly separate the kernels from the cob while preserving their shape and preventing damage. The separated kernels then fall onto a vibrating conveyor, where they are evenly spread out and gently moved forward for further cleaning and processing. The golden corn kernels are then passed through another round of clean water washing, combined with vibrating conveyors and multi-directional spray nozzles for about 2 to 3 minutes, thoroughly removing any leftover husk fragments, undersized kernels, dust, and impurities from the separation process. But don't be mistaken, this process does not significantly cause nutrient loss, as most of the corn's key nutrients are contained within the kernels and are not easily dissolved in water. After thorough washing, the corn kernels are transferred into a blanching machine using either hot steam or circulating boiling water. The blanching process lasts only about 1 to 2 minutes, but plays a critical role. It gently softens the kernels, inhibits spoilage enzymes, and helps preserve their crisp texture and natural golden color. Immediately after blanching, the corn is discharged onto a quick cooling system, typically using cold water at around 2.5 degrees Celsius to rapidly bring down the temperature. This sudden temperature shift helps maintain the kernel's firm structure and prepares them for the filling stage without allowing further cooking. Meanwhile, to ensure even cooling and prevent clumping, the kernels are gently moved across vibrating conveyors submerged in cold water. Although it may seem similar to freezing, this rapid cooling is a precise control step, a race against time to preserve the corn's crisp texture, vibrant color, and natural sweetness, ready for the final transformation. Once cooled, the corn kernels are transferred to an automatic filling machine, where they are dispensed into pre-sterilized cans. Depending on the product line, the cans may also be filled with a light brine or a mild corn syrup solution to help preserve freshness and enhance flavor. The light corn syrup used in canned corn is not harmful, as it primarily helps enhance flavor and preserve freshness, while health concerns are generally associated with the excessive consumption of high fructose corn syrup found in heavily processed foods. Immediately afterward, the cans pass through a vacuum sealing machine, which removes excess air before sealing them tightly with tin lids. After sealing, the cans move into a high-pressure steam chamber for sterilization, where the temperature is kept between 115 to 121 degrees Celsius to extend shelf life. Without sterilization, canned corn could only be preserved for a few days under refrigeration, but with proper sterilization, it can be safely stored for up to 1 to 2 years at room temperature. After sterilization, the cans of corn are rapidly cooled using a circulating cold water system to maintain the structural integrity of the cans and stabilize the quality of the product inside. The cans then move along an automatic labeling line, where product information, barcodes, production dates, and expiration dates are accurately printed and applied, ready to deliver their natural sweetness to soothe millions of hearts. In 2023, American farmers harvested around 300,000 acres of tomatoes, with fresh tomato production valued at about $1 billion. Florida and California are the country's tomato powerhouses, producing over 2/3 of all fresh tomatoes in the United States. Tomatoes are typically harvested at the end of summer and early fall, when the fruit reaches its peak ripeness and the flavor is at its best. This is the ideal time to use modern machinery, ensuring a quick harvest while maintaining the quality of each tomato. On the vast tomato fields spread across California, harvesting is no longer a manual job, but has been modernized with the help of advanced machinery. Automated tomato harvesters are designed to optimize efficiency, processing tons of fruit per hour while maintaining quality. When the machine starts, sharp cutting blades skillfully cut the plant's stem, bringing both the plant and fruit onto the conveyor belt. Here, a sophisticated vibrating system gently separates the tomatoes from the stems, ensuring that the delicate skin is not damaged. This process allows for a fast harvest while preserving the shape and vibrant color of the tomatoes. Once separated from the stems, the tomatoes pass through a modern optical system with smart sensors. These sensors quickly identify and sort the ripe tomatoes, removing impurities such as dirt, rocks, or underdeveloped fruit. After passing through the sensor system, there are still a few people standing on the conveyor belt responsible for further sorting. At the same time, they inspect and classify tomatoes based on size, color, and quality. From there, They are transported on a conveyor belt and gently moved into large storage bins. Modern tomato harvesting machines range in price from tens of thousands to hundreds of thousands of dollars, making it a significant investment. However, this investment pays off by greatly enhancing both yield and quality. With modern machinery and sustainable farming practices, American farmers play a vital role in meeting international demand, especially during times when supply chains are disrupted. This adaptability ensures a steady global tomato supply and strengthens the U.S.'s strong position in the international agricultural market. And now you can enjoy the harvest scene with realistic sound. The process of making ketchup begins when trucks loaded with fresh tomatoes roll in from the fields to the processing plant. This marks the start of a new journey for the tomatoes. When the trucks loaded with freshly harvested tomatoes arrive at the factory, the first step is a thorough cleaning process. High-pressure water jets are used to rinse the tomatoes directly in the truck beds. These jets blast away dirt, dust, and any residual debris from the fields, ensuring the tomatoes are as clean as possible before entering the processing system. This step is critical for maintaining food safety standards and preventing contamination during subsequent stages. The use of water jets also serves another important purpose: keeping the tomatoes hydrated. The added moisture helps maintain the tomatoes' firmness and prevents them from bruising or becoming damaged as they are moved along the production line. Once cleaned, a controlled stream of water is carefully introduced to the truck beds. This water creates a gentle but consistent flow that effectively guides the tomatoes out of the truck without causing unnecessary impact or stress on the produce. Tomatoes continue their journey to the buffer tank. Inside the buffer tank, the tomatoes are temporarily stored and continuously moved by the water to prevent overcrowding or stagnation. The tank acts as a staging area, regulating the flow of tomatoes into the next steps of the factory process. This ensures that the production line operates smoothly, even during peak delivery times when trucks arrive back to back. In the buffer tank, specialized equipment is used to separate and remove any stones or debris that may have mixed with the tomatoes during harvesting. From the buffer tank, water channels guide the tomatoes onto conveyor belts, specially designed to work with water. While moving on the conveyor belt, tomatoes are often washed with high-pressure jets to ensure that any dirt, sand, and any other impurities on the skin are removed. These conveyors further transport the tomatoes throughout the factory with care. The use of water as both a transportation and cushioning medium is crucial for protecting the tomatoes' skin and structure during their journey. This system is not only efficient, but also hygienic, as the constant flow of water helps wash away any residual dirt or debris. Overall, this water-based transportation process ensures the tomatoes are delivered to sorting and processing stations in pristine condition, ready for the next stages of production. As the tomatoes move from the buffer tank into the factory, they pass through a manual sorting station where workers carefully inspect them. These skilled individuals quickly identify and remove damaged, underripe, or overripe tomatoes to ensure only the best quality fruit continues along the production line. After the tomatoes are sorted and cleaned, they are transferred into large cooking vats or modern steaming systems, where they are cooked at high temperatures to soften them and make peeling easier. This process is crucial, not only to soften the tomatoes, but also to remove the skins while keeping the fresh, delicious pulp inside. The temperature and cooking time are carefully controlled to ensure the tomatoes are neither overcooked nor undercooked, but also ensures that the final ketchup has a smooth texture, free of any chunks, while preserving the natural sweetness of the tomatoes. Once the peeled tomato flesh moves along the conveyor belts, it is transported to a sorting area where workers carefully inspect and sort the fruit. This stage ensures that any remaining imperfections, such as discolored or damaged pieces, are removed, maintaining the high quality of the final product. The conveyor system keeps the tomatoes moving steadily, allowing workers to efficiently examine and handle each piece. This meticulous process is vital for producing consistent, top-grade tomato products like sauces and canned tomatoes, while also minimizing waste. After that, they move on to the next stage, dicing. In this process, the soft, prepared tomatoes are transferred into high-speed dicing machines that cut them into uniform pieces. Next, they will be transferred to the grinding stage. Here, the smooth and signature spices are added to ensure the unique flavor of the final product. After being ground, tomatoes are stored in large steel tanks to allow for homogenization and flavor development. During this time, the mixture is stirred continuously, helping all components like water, pulp, and solids blend together smoothly, ensuring a consistent texture for the final product. Typically, tomatoes are held in these tanks for several hours to a day. Once the tomato mixture reaches the ideal consistency and flavor, it moves to the automatic canning system for packaging. The process begins with sterilizing metal cans to ensure a hygienic environment that preserves the quality of the ketchup. The hot tomato sauce is then carefully dispensed into the sterilized cans using precise filling machines, which ensure the exact amount is added to each can without spillage. After filling, the cans are passed through an automatic sealing machine, where lids are securely crimped onto the tops. This step is critical for creating an airtight seal, preventing contamination and extending the product's shelf life. Finally, the cans are packed into sturdy cartons, ready to be shipped to distribution centers, supermarkets, and stores worldwide. This meticulous canning process ensures that the ketchup arrives fresh, flavorful, and ready to enjoy. In addition, in some other factories, tomatoes are canned immediately after peeling or immediately after dicing. That process depends on the manufacturer and the eating habits of consumers. This entire process not only guarantees the highest quality for the final product, but also showcases the clever use of technology to honor the natural gifts provided by nature. Every bottle of ketchup represents a journey from the farm to the dining table, as well as a symbol of the fusion between modern agriculture and industry. Ketchup is more than just a staple in every meal. It also plays a significant role in the U.S. economy. The ketchup industry provides thousands of jobs, from tomato farmers to factory workers. With the rise of major brands, American ketchup is also exported to many countries, helping to elevate the national brand value. This industry has not only improved the livelihoods of many rural communities, but has also created opportunities for sustainable growth in local economies. Quality control for ketchup in the factory's laboratory is a critical step to ensure the product meets the highest standards. Samples are taken from each batch to test for consistency, flavor, pH levels, and the balance of ingredients like sugar, salt, and acidity. The laboratory also checks for microbial safety, ensuring the product is free from harmful bacteria and contaminants. These rigorous tests guarantee that every can or bottle of ketchup leaving the factory is safe, flavorful, and of uniform quality, ready to meet customer expectations. Every year, from September to November, the vast fields of Illinois, known as the pumpkin capital of America, buzz with excitement as harvest season begins. This is a key time when farmers work hard to prepare for the harvest of bright orange pumpkins ready for the Halloween festivities. After 90 to 120 days of growth, pumpkins go through an incredible journey. They start as bright yellow flowers, develop into young fruits, and slowly turn into a vibrant orange color, showing they are perfectly ripe. Now, across fields stretching as far as the eye can see, the bright orange pumpkins stand out against the green leaves, creating a lively scene that looks like a sea of glowing golden stars. A beautiful sign of a successful harvest season. Pumpkin harvesting machines are specially designed to make the harvesting process both efficient and precise. With a wide 150 centimeters intake system, these machines gently gather pumpkins from the ground, even when they are hidden under thick layers of leaves, without causing any damage. The pumpkins are then moved through two parallel conveyor belts. The first belt removes dirt, dry leaves, and other debris using a combination of vibration and air blowers. The second belt transports the pumpkins to a sorting table, where their quality is carefully inspected. The machine stands out with modern features like an adjustable automatic container that protects the pumpkins from impact, along with a smart control panel and integrated cameras that allow operators to easily adjust technical settings. With a productivity rate of 22,000 to 33,000 pounds per hour, the machine significantly reduces labor and costs while maintaining top product quality. This technology not only boosts efficiency, but also helps protect the environment, paving the way for more sustainable agriculture. While machines dominate large-scale pumpkin harvesting, American farmers still rely on hand harvesting for specific purposes, such as picking pumpkins for festive decorations or high-end culinary use. This traditional method, used for selecting decorative pumpkins or premium culinary varieties, ensures each pumpkin is handled with care to preserve its shape, color, and overall quality. In addition to pumpkins, pumpkin seeds are not just a byproduct, but also bring significant economic value to American agriculture. With high demand in the food and pharmaceutical industries, pumpkin seeds are used to produce products like seed oil, snacks, and ingredients for functional foods. As a result, harvesting pumpkin seeds requires a more complex process compared to harvesting the fruit, ensuring both quality and maximizing yield. The process begins with a specialized gathering machine that moves across the pumpkin fields, collecting and arranging the pumpkins into neat rows. This step helps optimize the next stage of harvesting the seeds. Once the pumpkins are lined up, the seed harvesting machine takes over. This machine is equipped with a large rotating drum, fitted with sturdy spikes that pierce each pumpkin to secure it and guide it into the machine for processing. Here, the pumpkins are taken to the crushing area, where the fruits are completely broken apart. The seeds are carefully collected using a precise filtering system, while the pumpkin flesh is discarded at the back and spread evenly across the fields. This flesh naturally decomposes and becomes an organic fertilizer, enriching the soil. After harvesting, the seeds are collected into an integrated container within the machine. Once the container is full, the seeds are transferred to large trucks with storage capacities ranging from 30,000 to 50,000 pounds of pumpkin seeds. This setup makes it much more convenient to transport the seeds to processing facilities. After pumpkins are harvested from the fields, they are loaded onto large trucks and transported to the processing plant. Here, each pumpkin goes through a series of modern procedures to ensure the final product meets the highest quality standards before reaching consumers. The first stage is washing, where the pumpkins are placed into a system with high-pressure water jets combined with conveyor belts. This quickly removes dirt, sand, and other surface impurities, leaving each pumpkin clean and fresh in appearance. Next, the pumpkins are taken to the manual inspection and sorting area. Once labeled carefully, the pumpkins are placed into sturdy cardboard boxes. These boxes are designed not only to protect the pumpkins during transportation, but also to optimize storage space. Once the packing process is complete, the boxes are loaded onto trucks, ready to begin their journey to supermarkets, restaurants, or directly into the hands of consumers. If the process of handling pumpkins focuses on preserving their freshness, then the handling of pumpkin seeds requires meticulous care to maximize their nutritional value. When pumpkin seeds are brought into the factory, the first step is to put them into a specialized rotating machine. This machine uses a centrifugal mechanism to clean the seeds, removing impurities like dirt, sand, and any leftover pulp. This ensures that the surface of the seeds is clean and ready for the next steps in the processing. Next, the seeds are transferred to an optical sorting machine. This system uses advanced laser technology to analyze the size, color, and shape of each seed. Seeds that meet the quality standards move on to the next step, while those that don't, such as hollow, cracked, or discolored seeds, are removed to ensure the final product's quality is not compromised. After sorting, the seeds are placed in an industrial dryer. Here, they are dried at carefully controlled temperatures, typically maintaining the seed moisture level at an ideal range of 6 to 8%. In addition, the seeds are fed into a modern screw press system, a machine specifically designed to extract oil using a mechanical pressing method. This advanced technology ensures maximum oil extraction without the use of chemicals, thereby preserving the natural flavor and valuable nutritional properties of pumpkin seed oil, such as essential fatty acids, vitamins, and antioxidants. A standout feature of this process is its commit kitchens. Finally, the processed pumpkin seeds are sent to the packaging area. They are packed into large bags, each capable of holding between 2,000 and 3,000 pounds. These bags are then transported to the next processing facility or directly exported to international markets. Pumpkins are a beloved symbol of American culture, seamlessly blending economic value, tradition, and culinary charm. Generating an impressive $2 billion annually, pumpkins contribute significantly to the economy through processed products like hearty soups, velvety pies, and crunchy, nutritious seeds, as well as decorative pumpkins that have become iconic during the fall season. During Halloween, pumpkins truly shine as radiant jack-o'-lanterns, bringing joy and festive spirit to families everywhere. Culinary traditions also celebrate pumpkins, especially through the iconic pumpkin pie, a Thanksgiving staple that embodies warmth and togetherness. Moreover, the king of all pumpkins, a colossal 27749-pound marvel grown in Minnesota in 2023, stands as a testament to the wonder and grandeur of this cherished crop. From festive decor to culinary delights, pumpkins continue to hold a special place in the hearts of Americans. To ensure fresh and high-quality pumpkins are ready for the Halloween season, farmers start preparing the soil in early spring. Modern plowing machines are used to loosen compacted soil and remove weeds. At the same time, organic fertilizers are added to enrich the soil, creating ideal conditions for the pumpkin plants to thrive. In late spring, after the soil has been carefully prepared, farmers use specialized seed planting machines to plant pumpkin seeds. From tiny pumpkin seeds begins a magical journey, unfolding through each stage. Sprouting vibrant green shoots, blossoming brightly, being pollinated by wind and bees, and growing into full, vibrant fruits brimming with life. So now you've got a full picture of how farmers grow and harvest billions of pounds of pumpkins every year to meet the huge demand for both food and festivities. Exploring the vast fields of California, it's easy to see why this state is called the carrot capital. California's warm, sunny climate, sandy, well-drained soil, and advanced irrigation systems create the perfect environment for carrots to thrive. Thanks to these ideal conditions, carrots have become not only an essential crop, but also a major economic contributor, with an estimated value of $1.823 billion in 2023. The success of the carrot industry begins with soil preparation and seed planting, where advanced technology plays a crucial role. Before planting, the soil is carefully treated using modern machinery to ensure it is loose and well-drained, two key factors for healthy plant growth. Next, the soil is leveled and shaped into raised beds with appropriate spacing to ensure proper drainage and ease of crop. Once the soil has been prepared, an automatic seeder is introduced. Healthy carrot seeds that have been treated with chemicals are poured into the seeder's container. Smart seeders equipped with GPS and precise sensors ensure seeds are evenly distributed with perfect spacing between rows. The spacing between carrot seeds sown using a seed planter is typically 0.8 to 2 inches. This spacing ensures that the plants have enough room to grow without overcrowding, allowing the carrots to develop straight and uniformly. Throughout the growing process, American farmers take meticulous care of carrots. Automated irrigation systems and sensors that monitor soil temperature and moisture ensure the ideal environment for the crops to thrive. Farmers also use organic fertilizers and advanced pest management techniques to protect the carrots while keeping the process environmentally friendly. Every stage of growth is closely monitored to ensure the plants grow uniformly and meet high-quality standards, satisfying the large demand both domestically and internationally. When the lush green fields of carrots begin to fade to a pale shade, it's a clear sign that harvest season has arrived. After 70 to 80 days of growth, the carrots reach their peak condition, with smooth, firm skins and a vibrant orange color. To ensure an efficient harvest and maintain the highest quality, farmers use advanced machinery that makes the process quick, precise, and labor-saving. The harvester they use is designed to handle the entire process, from lifting carrots out of the ground to basic cleaning and separating the leaves from the roots. The cutting blades at the base of the machine slice through the stems and gently lift the carrots out of the soil without causing any damage. Simultaneously, an integrated conveyor system moves the carrots upward, where dirt and debris are partially removed using fans and a vibration mechanism. Once the carrots are cleaned, the leaves are cut off and left on the field, reducing transport weight and returning organic matter to the soil. The cleaned carrots are then transferred directly into large bins on trucks moving alongside the harvester. This machine significantly improves efficiency, saving both time and labor compared to traditional manual harvesting methods. In some areas, a combined harvesting system with 2 machines is used. These machines work closely together to complete the process efficiently. The first machine removes all the carrot tops using a specialized cutting system that only removes the leaves without affecting the carrots underneath. The leaves are left on the field to improve soil fertility. The second machine uses deep cutting blades to gently lift the carrots from the soil without causing any damage. The cleaned carrots are then transferred onto a conveyor belt and moved directly into large bins on nearby trucks, while the soil is left behind in the field. This process ensures high-quality carrots, reduces costs, and increases overall harvesting efficiency. The use of advanced machinery in carrot harvesting has truly revolutionized American agriculture, prioritizing efficiency, quality, and sustainability. Modern harvesting machines with integrated features have made the process faster, more precise, and cost-effective than ever before. Additionally, high-tech machinery optimizes labor resources by freeing workers from physically demanding and time-consuming tasks. This not only lowers labor costs but also reduces pressure on workers, allowing them to focus on other important aspects like quality control or preparing for future crops. More importantly, the use of modern machinery brings consistency to the production process. Carrots harvested with advanced machines not only meet strict standards for shape and size, but also retain their freshness thanks to the quick and precise handling. This is especially critical in today's market, where quality demands are high, particularly in export markets that adhere to rigorous international standards. These machines ensure that every carrot from field to table meets consumer expectations with consistent quality. Beyond improving efficiency, high-tech machinery in carrot harvesting carries significant benefits for sustainable agriculture in the U.S. Automated systems reduce resource waste, limit emissions from transportation, and enhance soil regeneration. This demonstrates a clear synergy between science and practical farming, creating a production process that is both efficient and environmentally friendly. The use of advanced machinery also reflects the forward-thinking approach of American farmers in building a modern, competitive agricultural industry. They not only prioritize higher yields, but also focus on sustainable practices and innovation. These machines not only boost production capacity, but also allow farmers to dedicate more time to strategic tasks, such as developing better crop varieties or refining farming techniques. Now let's feel the most realistic harvesting processing with vivid sound. After harvest, carrots are transported to factory for further processing. At the factory entrance, carrots are unloaded from trucks onto a conveyor system, where they are gently and continuously moved along. The conveyor transports the carrots into large storage bins designed to protect the produce from damage. These filled bins are then quickly and efficiently transported into the factory by forklifts. This process not only optimizes time, but also preserves the freshness and quality of the carrots before they move on to the next stages of processing. Next, the carrots are transferred to a modern washing line. The carrot washing process in the factory begins with the carrots being transferred from the main conveyor to a specialized washing system. First, they pass through a large water tank equipped with high-pressure water jets that remove dirt and soil from the surface. Next, the carrots move through rotating drums or conveyors with soft brushes that scrub away any stubborn dirt without damaging their natural skin. The water used in this process is continuously filtered and recycled to ensure efficiency and environmental friendliness. Following this, the carrots are rinsed once more with clean water to ensure they are completely sanitized. Finally, they are gently dried on a conveyor before being moved to the next stages of processing. This meticulous process ensures that each carrot meets the highest hygiene standards before reaching consumers. After being thoroughly washed, the carrots are moved to a size sorting conveyor equipped with special rolling bars. These bars have gaps of varying sizes, allowing smaller carrots to fall through while larger ones continue along the conveyor. This process ensures precise sorting of carrots by size before they proceed to the next stages of processing. Next, the carrots are sent to an automated sorting system equipped with advanced sensors. These sensors scan each carrot to assess its size, color, and shape, then automatically sort them into appropriate categories. This process is not only fast but also highly accurate, ensuring optimal product quality before processing or packaging. After being sorted, the carrots are transferred to an automated packaging line. Here, they are precisely weighed to ensure the correct weight for each type of packaging. The carrots are then placed into bags or boxes, with the automated system sealing or closing them and applying product labels. Finally, the completed carrot packages are stacked onto pallets, ready for transportation to stores or distributors. Besides, they are also made into carrot juice. Let's witness this process. Bell peppers, often called the colorful stars of the vegetable world, stand out not only for their eye-catching hues but also for their multicolored, multi-flavored personality. From green, yellow, and orange to fiery red, each color has its own story. Green peppers are crisp and slightly bitter. Yellow and orange bring a gentle sweetness, while red is the sweetheart queen with the highest sugar content. The secret behind this vibrant palette lies in their ripening process. All bell peppers start out green, gradually changing color as they mature. In other words, a red bell pepper is just the grown-up, mature version of its green self. So where are these stars cultivated? The answer is everywhere, from sun-drenched fields to cutting-edge greenhouses. With nutrient-rich soil, consistent watering, and a little love from dedicated farmers, bell pepper plants thrive as if they know they're destined to become global celebrities on dining tables worldwide. More than just a familiar ingredient, each bell pepper is a testament to the hard work and skill of farmers. Every pepper carries a story worth cherishing. And while their journey from harvest to processing may seem complex, don't worry. Stick with me and we'll explore the final steps where these peppers transform into dazzling culinary stars, ready to elevate any dish you love. From the moment a bell pepper seed sprouts to when it blooms and bears fruit, it takes about 60 to 90 days, a perfect reminder that great things truly come to those who wait. And when those ripe, vibrant peppers are finally ready, the harvest becomes a magical new chapter, where modern technology and human skill blend seamlessly. The combination of high-tech machinery and human expertise doesn't just speed up the harvesting process, it ensures that every pepper is picked with care, preserving its freshness and quality. Precision-driven machines paired with the sharp eyes of experienced farmers create a process that is both efficient and delicately executed. Thanks to this harmonious collaboration, vast bell pepper fields transform from daunting expanses into impressive stages of productivity. Peppers are swiftly and meticulously harvested, ready to embark on their next journey, gracing kitchens and elevating dishes across the globe. One key advancement is the use of robotic harvesters that carefully pluck the peppers from the plants without harming the surrounding foliage. These machines are designed to operate with speed and precision, significantly reducing the time and labor costs associated with manual harvesting. In larger farms, conveyor-based systems transport the harvested peppers directly from the field to processing stations, streamlining the supply chain. Industrial machinery also minimizes post-harvest losses by ensuring consistent handling, reducing bruising or spoilage. For instance, automated sorting and grading machines categorize bell peppers by size and quality, preparing them for market or further processing. Such systems not only save time, but also ensure that farmers meet the strict quality standards of international markets. While the vast outdoor fields of bell peppers showcase an impressive harmony between advanced machinery and human effort, the greenhouse harvest tells a gentler, more personal story. In these controlled environments, bell peppers grow faster than their outdoor counterparts, often needing just 60 to 80 days to be ready for harvest. This is thanks to stable temperatures, ideal humidity, and perfectly optimized lighting. Compared to fields that rely heavily on unpredictable weather, greenhouse farming is a leap forward in shortening growth times and enhancing quality. Here, the skilled hands of farmers play a crucial role. Each pepper is carefully picked and handled with care, ensuring its freshness and preventing any blemishes. Their keen eyes and delicate touch leave no room for imperfection. Yet even within the warm, controlled space of the greenhouse, technology has made its mark. Modern harvesting robots, equipped with flexible arms and intelligent recognition systems, have joined the effort. These robots gently pick each pepper, analyzing color and ripeness to ensure only the best are harvested. The sight of human hands working in harmony with robotic arms paints a vibrant, modern picture of agriculture, one that remains deeply rooted in tradition. Greenhouses, with their seamless blend of technology and human dedication, are more than just places for cultivation. They stand as symbols of smart farming's future, a future where innovation and hard work unite to deliver the finest produce to the world. Once freshly harvested bell peppers are ready, they embark on an exciting journey to modern processing facilities where every step is carefully managed to preserve their quality and flavor. Large quantities of vibrant peppers from different regions converge here, creating a dazzling display of colors. The first stop is the cleaning line, where advanced machinery takes charge, thoroughly washing away dirt and impurities. Using high-pressure water systems combined with flexible nozzles, each bell pepper is meticulously cleaned without damaging its delicate surface. Next comes the sorting stage, where cutting-edge optical sensors and scanners serve as sharp eyes, categorizing peppers by color, size, and ripeness. Whether bright red, sunny yellow, or vibrant green, each pepper is sorted to meet the specific demands of various markets. While machines handle much of the heavy lifting, the skilled hands of workers remain essential. They inspect each pepper, removing those that don't meet quality standards, whether bruised or underripe, ensuring only the finest make it through. This seamless blend of advanced technology and human attention to detail results in a process that's both fast and highly effective. After sorting, the peppers are moved to automated packaging lines. They're packed into bags, boxes, or cartons, ready to be shipped around the globe. But the story doesn't end there. Some peppers go on to be further processed into canned products like pickled peppers, sliced peppers, or roasted peppers. In these specialized lines, the peppers are heat-treated, trimmed, and sealed in cans using sophisticated systems that guarantee the highest food safety standards. This harmonious combination of human craftsmanship and cutting-edge technology not only optimizes the process, but ensures that each bell pepper retains its freshness, vibrant color, and nutritional value. It's a proud journey from farm to table, a testament to the dedication and modernization of agriculture and food processing. Let's not keep you waiting. We are now at a Brussels sprouts field in California, the leading region for Brussels sprouts production in the United States. With its cool coastal climate and fertile soil, this area provides the perfect environment to grow these small, nutrient-packed vegetables. Typically, Brussels sprouts take about 80 to 100 days to grow from planting to harvest. Fall and early winter, when the temperatures are crisp and cool, are the ideal times for harvesting. This cooler weather allows the sprouts to thrive, giving them a crunchy texture and their best flavor. To ensure top quality and high yields, farmers here use advanced and specialized machinery. These machines are designed specifically to harvest Brussels sprouts quickly and efficiently, making the entire process smoother and more productive. So how do these modern machines work to harvest Brussels sprouts? Out in the vast fields, specialized harvesting machines slowly move along the rows of Brussels sprouts, performing their tasks with remarkable precision. Equipped with sharp cutting blades, these machines cut the stalks cleanly at the base in an instant as they pass by, preserving the freshness of the plants and minimizing any damage. Farmers sitting on the machines skillfully lift each stalk and place it into the built-in stripping system. Here, the tiny Brussels sprouts are separated from the stalks using rotating drums or stripping blades. Once detached, the sprouts are quickly transported along conveyor belts inside the machine to storage bins, ready for the next steps in their journey. One of the standout features of these machines is their advanced built-in sensors, which can sort Brussels sprouts during the harvesting process. As the sprouts move along the conveyor belt, the sensor system scans each one to identify any that don't meet quality standards, such as those that are damaged or too small. These imperfect sprouts are automatically removed through a separate sorting mechanism, ensuring that only fresh, high-quality sprouts are stored in the bins. Meanwhile, the leftover stalks and leaves are returned directly to the field, acting as a natural fertilizer. This not only enriches the soil, but also helps maintain its fertility for the next planting season. Semi-automated harvesters significantly reduce the time and labor required compared to traditional hand harvesting methods. A single machine, operated by a small team, can process acres of Brussels sprouts in a day, making it an ideal solution for large-scale farming operations. At the same time, it allows for greater flexibility and adaptability in the field. For example, workers can adjust the machine settings to suit varying stalk sizes or to harvest selectively based on ripeness. Another advantage is sustainability. By combining the power of machines with human precision, semi-automated harvesting reduces waste and minimizes the environmental impact of farming. The efficiency of the process means less energy consumption sources used per harvested sprout. Moreover, the ability to selectively harvest ensures that only mature sprouts, leaving smaller ones to continue growing. The semi-automated harvesting of Brussels sprouts represents a perfect marriage of technology and humans. This approach not only ensures the delivery of fresh, high-quality sprouts to Technology doesn't stop there. Step further with fully automated machines that significantly reduce the need for human labor. These machines are similar in design to the previous harvesters, but come equipped with intelligent robotic arms and advanced sensor systems. After the sharp cutting blades neatly sever the Brussels sprout stalks at the base, the robotic arms, with incredible precision, swiftly grab each stalk and gently place it into the stripping system. The sensors are programmed to identify and handle each stalk with care, ensuring no sprouts are missed or damaged during the process. This level of automation not only increases efficiency, integrated sensors, and automatic sorting capabilities, the harvesting process becomes faster and more precise, eliminating substandard produce right from the start. This approach reduces the cost of manual labor and saves time in subsequent processing stages. Additionally, returning the leftover stalks and leaves to the fields helps enrich the soil, promoting sustainability for future crops. The seamless combination of technology and nature is the key to building a well-rounded and sustainable future for agriculture. The application of technology doesn't stop in the fields. It continues to play a crucial role in processing Brussels sprouts at the factory. After being harvested, the sprouts are loaded into large bins on trucks and transported to a modern processing facility. Once they arrive, the process begins as the bins are emptied into a large holding tank. From there, the Brussels sprouts are moved onto the first conveyor belt, which carries them to the sorting area. At this stage, larger debris such as stalks, leaves, or leftover plant material is removed using mesh screens and automatic vibrating mechanisms. Once sorted, the Brussels sprouts are sent to the washing area, where they are cleaned with high-pressure water jets. This process thoroughly removes dirt and any remaining soil from the surface, ensuring the Brussels sprouts are perfectly clean and ready for the next steps. Next, the standard-sized Brussels sprouts move to the sorting area, where they travel on a specially designed conveyor belt with gaps between its slats. When sprouts reach the appropriate size, they automatically drop onto a secondary conveyor belt, thanks to this clever design. The sprouts that drop onto the secondary belt are then taken to the manual inspection area. Here, workers perform a final check for color and freshness. This crucial step ensures that only the highest quality Brussels sprouts are selected for the next stages of processing. After going through thorough sorting and inspection, the Brussels sprouts are sent to the trimming area. Here, automated blades swiftly remove any wilted leaves or unnecessary stem parts, giving each sprout a clean, polished look and perfect shape. Finally, the Brussels sprouts move to the packaging area. At this stage, automated machines portion them into bags or boxes with precise weights, ready for storage or transportation. This process not only ensures consistency and quality, but also optimizes time and efficiency, delivering a flawless product to consumers. As you can see, every vast field starts with tiny seeds, and Brussels sprouts are no exception. With the help of modern technology, the seedling process has become a fascinating step, where these small seeds are carefully nurtured to prepare for their journey toward lush green growth. First, seed trays are prepared in advance and placed into a system that fills each compartment with nutrient-rich soil. This soil is meticulously processed to remove impurities, ensuring the ideal foundation for the seeds to thrive. Next, the Brussels sprout seeds go through an automatic sorting process to ensure they are uniform in size and quality before being precisely sown into individual compartments of soil-filled trays by a seeding machine. These trays are then neatly arranged on moving racks and transported to the nursery care area. After 4 to 6 weeks, once the seedlings have grown strong and healthy, they are ready to be transplanted into the vast fields of California. At the start of summer, specialized plowing machines get to work, efficiently breaking up the soil to create a loose, nutrient-rich layer. This process not only removes weeds and leftover debris, but also improves soil aeration, creating the perfect environment for Brussels sprouts to thrive. Once the soil is perfectly prepared, modern planting machines take over the job. These machines are specially designed to maximize efficiency, helping farmers plant seedlings quickly and accurately. Each young plant is gently lifted from its seed tray and placed into pre-made holes in the soil, spaced evenly to provide the ideal room for growth. At the same time, the machine's automated system carefully fills the soil back around the base of the plants, securing them firmly and protecting the delicate roots from environmental factors. After planting, the Brussels sprouts fields are watered regularly to maintain the right level of moisture for healthy growth. Throughout the growing process, farmers closely monitor the plants, providing essential nutrients as needed to ensure they grow strong and healthy. The use of specialized machinery plays a key role, not only reducing the labor required, but also increasing precision and efficiency in every step of the care process. And there you have it, a complete overview of how American farmers harvest and process thousands of tons of Brussels sprouts each year. This journey showcases the perfect blend of modern technology and the dedication and skill of hardworking people. California, Washington, and Idaho, with their fertile soil and ideal climates, are the top onion-producing states in the U.S. Planted in well-drained fields, onions take 5 to 6 months to fully develop underground, while their green tops sway gently in the breeze. As they mature, their outer layers dry into the familiar papery skin, signaling that harvest time is near. By late summer, when the bulbs have reached their perfect size and flavor, advanced harvesting machines and skilled farmers work together to lift them from the soil, beginning their journey from field to kitchen. On large-scale onion farms across the U.S., modern onion harvesters play a crucial role in helping farmers efficiently lift onions from the soil while preserving their quality. This advanced technology optimizes the harvesting process, reduces manual labor, and significantly increases productivity on vast farmland. Once in position, the harvester's sharp undercutting blade moves just below the soil's surface, carefully slicing through the roots to loosen the onions. This allows the onions to be lifted smoothly without being dragged or broken, ensuring their protective outer layers remain intact. Immediately after, lifting belts and rotating tines gently pull the onions from the soil. These rotating tines are specifically designed to hold the onions in place, preventing them from falling or being damaged by excessive force. This step is essential to ensure that the onions maintain their shape and quality before moving on to the next stages. Once lifted, the onions travel along an integrated conveyor belt, where they undergo an initial cleaning process to remove soil and debris. First, soft brushes gently sweep over the onions, dislodging loose dirt while keeping the onion surface undamaged. Next, high-powered air jets blow away any remaining dust and small particles. This preliminary cleaning step ensures that the onions remain in top condition before reaching the sorting and collection stage. After cleaning, the onions are automatically sorted by size and quality while still on the conveyor system. Onions that meet the required standards continue to large storage bins or specialized trailers, where they are gathered for transport to warehouses or processing facilities. Onions that do not meet the quality standards are separated and used for secondary products such as onion powder, frozen onions, or processed food ingredients. Thanks to these highly efficient harvesters, farmers can handle thousands of tons of onions per day, minimizing waste and ensuring a steady supply to processing plants and markets. Alongside modern combine harvesters, farmers in some regions of the U.S. still utilize windrower onion harvesters as an efficient method for harvesting onions. These machines carefully lift the onions from the soil and perform an initial cleaning process. After this cleaning step, the onions are not immediately collected, but instead arranged in long windrows across the field, allowing them to continue drying naturally under the sun. This additional drying time hardens the outer skin, reducing moisture content and significantly lowering the risk of spoilage during storage and transportation. Pickup harvester then moves along the rows, gently lifting the dried onions onto a conveyor system. The conveyor removes any remaining dirt and loose outer skins before transferring the onions into bulk storage bins or transport trailers. This two-step harvesting process ensures that onions are properly cured, preserving their quality and extending their shelf life before reaching packaging facilities. While machines dominate large-scale farms, hand harvesting onions remains an essential practice in the U.S. This method preserves onion quality, prevents bruising, and ensures the freshest product reaches consumers. During harvest season, workers use hand tools such as small shovels, digging forks, or specialized blades to loosen the soil around the onions. This step makes it easier to pull the bulbs without damaging their protective outer layers. Immediately after being pulled from the ground, onions undergo an initial cleaning process right in the field, to remove excess soil and debris. After this, onions are laid out in long rows across the field and finally packed into hundreds of thousands of sacks stretching across the farmland. Thanks to the harmonious combination of the skilled craftsmanship of American farmers and advanced harvesting systems, a modern onion harvester can process several tons of onions per hour, significantly boosting farm productivity. With this technology, the U.S. onion industry not only achieves high production levels, but also streamlines the harvesting process, delivering high-quality onions to consumers worldwide. Upon arrival at the factory, trucks carrying up to 25 tons of onions each unload their cargo onto conveyor belts, where the onions are transported to massive storage warehouses. Before being stored, the onions are first transferred to the preliminary cleaning stage, where they pass through vibrating screens, filtering grids, and powerful air blowers that effectively remove dust, soil, and debris from the fields. Any damaged, cracked, or spoiled onions are separated at this stage to maintain high quality. This careful handling at the initial stage helps preserve the freshness and quality of the onions before they undergo the next steps in the processing chain. For fresh whole onions, they continue along a modern processing line, where each step is meticulously executed to maintain the highest quality. First, onions go through a mechanical sorting system, ensuring they meet market standards. Mechanical sifters and size grading conveyors separate them into small, medium, and large categories, while weight-based sorting systems ensure uniformity in packaging. Any onions that do not meet size or weight requirements are diverted for secondary processing, such as dehydration or onion powder production. Next, the onions undergo dry cleaning methods to further remove any remaining dirt while preserving their natural protective skin. Soft rotating brushes gently polish the onions, while high-pressure air jets blow away loose particles. Once sorted and cleaned, the onions pass through an advanced optical sensor-based sorting system, which uses high-resolution cameras and infrared technology to detect any imperfections, discoloration, or internal defects. This ensures that only the highest quality onions proceed to the final packaging stage. Next, the onions move to the automated packaging stage, where they are packed into breathable mesh bags ranging from 2 to 50 pounds. For bulk distribution, onions are packed into large sacks or bins with a capacity of up to 2,000 pounds, ready to be supplied to further processing plants. For pre-cut onion products, after the initial inspection, onions go through a carefully designed high-tech process. First, they undergo an automated cutting and peeling process to ensure cleanliness and product consistency. Specialized cutting machines trim both ends of the onions, removing the roots and tops to prepare them for more efficient peeling. The ultra-sharp stainless steel blades, treated with anti-wear technology, can process thousands of onions per hour without damaging their structure. After this, the automated peeling system quickly removes the outer skin using rotary blades or high-pressure air jets to retain the onion's core while minimizing waste. Next, these tear-inducing bulbs enter a powerful washing system that removes dirt and any leftover debris, making sure they are clean and ready for the next steps. Once peeled, the onions move to a high-precision cutting system, where they are sliced, diced, or minced according to the required product specifications. The cutting machines are equipped with sensors to adjust thickness, ensuring uniform sizing and meeting industrial food processing standards. Thanks to modern technology, these machines can process several tons of onions per hour, significantly boosting production efficiency on a large scale, while also minimizing raw material loss and reducing waste in the processing line. And my friends, there are also some other modern factories with incredible processing systems that I think you'll find fascinating and absolutely unmissable. Impressive, isn't it? These cutting-edge machines in the onion coring and peeling process can handle thousands of onions per hour, delivering razor-sharp precision with cuts accurate to the millimeter, ensuring efficiency and consistency on an industrial scale. And the result of this advanced process is gleaming, uniformly sized onions, meticulously prepared to meet the highest quality standards. After coring and peeling, the onions proceed to the dicing stage, where they are precisely cut into uniform cubes. After being thoroughly washed, they are sent to the packaging process, ready to be delivered to consumers worldwide. Modern onion processing plants in the U.S. play a crucial role in ensuring efficiency, quality, and food safety in the agricultural supply chain. These facilities utilize advanced technologies such as automated sorting, optical sensors, and precision cutting systems to process massive volumes of onions quickly and consistently. But before we dive into the magical factories, let me reveal some fascinating secrets about these golden beans and let you enjoy the picturesque harvest on the vast soybean fields. First, while Brazil, often dubbed the soybean king, accounts for 39% of global production, but across the ocean, the U.S. proudly claims its soybeans are premium grade. Will Brazil's massive production be enough to outshine the U.S. forever? Or will superior quality rise to the top and stage an impressive comeback? Don't hesitate to drop a comment below and share your thoughts with everyone. Soybeans particularly love warm weather, thriving in temperatures between 20 to 30 degrees Celsius, with just the right amount of rainfall throughout the growing season and fertile, nutrient-rich soil. A typical soybean plant, from a tiny seed to a fully grown pod-filled plant, needs at least 80 to 120 days to complete its growth cycle, depending on the variety and environmental conditions. Every September, as the cool autumn winds begin to whisper and the golden hues start to dominate the landscape, it's also the signal for farmers that the harvest season has arrived. Under the brilliant golden sunlight, the combine harvesters appear as sophisticated machines of modern agriculture, ready to carry out their harvesting task. With their large size and sharp cutting blades, these machines move gently yet decisively through the soybean fields, causing rows of plants to bow down. The soybeans are immediately fed into the machine, where the threshing system works with precise accuracy. Specialized parts of the machine work in perfect harmony, separating the beans from their pods without compromising their quality, preserving the color and value of every single bean. With impressive capacity, each combine harvester can harvest over 45 tons of soybeans in just 1 hour. When the hopper is full, the machine's arm extends, automatically unloading the golden beans into a waiting truck. Once the work is done, the harvested soybeans are transported to modern factories, where technology takes over the next phase of processing, turning fresh raw materials into refined, valuable products. Specialized trucks enter the factory, and immediately, bins full of golden beans pour into the feeding mouth on the ground. An underground system is ready to cleanse the beans before they are stored. The beans continue their journey on a conveyor belt into the screening system. Large fans blow strong air currents, blowing away dirt and light impurities like dry husks and leaves, which are then directed to the waste outlet above. Meanwhile, heavier impurities like stones and dirt that can't be blown away are separated using a centrifugal filtration system with different mesh layers, allowing only the standard soybeans to continue their journey. After being cleaned, the soybeans move to an automatic drying system. Here, alternating hot and cold airflow passes through, allowing moisture inside the beans to evaporate without affecting the nutritional quality or structure of the beans. Finally, the highest quality beans are poured into towering silos that reach up to several dozen meters in height, with a maximum capacity of up to 50,000 tons, preparing them for the next stages of processing. First, let me take you on a tour around the tofu factory to explore how these meat-free blocks are created. The production process begins with the preparation of raw materials. Dried soybeans are fed into an automatic washing system and then soaked in large water tanks for 6 to 12 hours. This soaking process helps the beans absorb water and soften, making it easier for the next grinding step. Once the beans have reached optimal moisture content, they are fed into a grinding system. Here, the beans are ground with a certain amount of water to create a mixture of soy milk and soybean pulp. Depending on the technology used, factories may apply a dry grinding method, which requires longer soaking times, or a wet grinding method, which requires shorter soaking times. The mixture after grinding is passed through a centrifugal filtration system to separate the soybean pulp from the pure soy milk. The soy milk continues to the next processing stage, while the pulp is sent to a separate area to be used as animal feed or made into other products such as cereal or fiber-rich foods. After being properly filtered, the soy milk is pumped into an automatic heating system, where the temperature is strictly controlled between 95 degrees Celsius and 100 degrees Celsius. This boiling process not only helps eliminate bacteria and remove natural toxins in the soybeans, but also brings out the distinctive flavor of tofu. Once it reaches the required temperature, the soy milk is immediately transferred to a coagulation tank to begin the curdling process and form the tofu structure. The hot soy milk is transferred to a large container where coagulating agents like nigari salt or food-grade gypsum are added. The mixing machine stirs the solution to trigger the curdling of the protein, forming solidified clumps. For soft tofu products, the coagulation stirring process doesn't take place. Instead, the soy milk is sprayed into long bags or square boxes, then sealed and immediately placed in a cold water bath to cool. This process helps preserve the softness and loose texture of the soft tofu, while also ensuring the product stays fresh longer. After the coagulation process is complete, the curdled mixture is placed into molds to remove excess water. Here, the press applies just the right amount of pressure to compact the curds, giving the tofu a firmer texture. After being pressed, the tofu is cooled to reach the ideal temperature, which helps the product achieve better firmness and stability. During the cooling process, the tofu is passed through a cooling system, either using cold water or air. Afterward, the tofu is cut into pieces using automatic cutting blades that are gentle yet precise. Next, the tofu is immediately placed into packaging boxes through an entirely automated production line. Before sealing, a little clean water is sprayed inside the box to maintain moisture, preventing the tofu from drying out and keeping it fresh for a longer time. After packaging, the tofu products go through a sterilization process. Sterilization is carried out using heat treatment, where the tofu packages are heated to temperatures between 85 degrees Celsius and 90 degrees Celsius for a set period, then quickly cooled. Finally, after completing the production process, the tofu is stored in a warehouse at temperatures between 4 degrees Celsius and 10 degrees Celsius before being distributed to the market. For soy milk, the preparation process is similar to that of tofu production. However, during the cooking stage, flavorings such as salt and sweeteners are added and thoroughly mixed with the soy milk to ensure a consistent and stable flavor. Once the soy milk has completed the processing steps, it is transferred to automated packaging systems where it is bottled or packed into paper cartons. For bottled soy milk products, which typically have a longer shelf life than carton-packaged ones, the empty bottles are first carefully checked using a laser scanner and washed with clean water before being filled. The modern filing system uses sensor technology to accurately measure the amount of soy milk to be poured into each bottle. After filling, the bottles are sealed and proceed to the final sterilization stage. Once the sterilization process is complete, the bottles continue on a conveyor belt, passing through a system of water sprays and air blowers to quickly cool them down before being labeled by an entirely automated system. If soy milk is packaged in a carton, it will look like this. At this point, the soy milk bottles are ready to be distributed to consumers. However, the journey of the soybeans doesn't stop here. The beans continue their transformation into golden, nutrient-rich soybean oil. From the storage silos, soybeans are sent through a screening system, where gentle vibrations help remove impurities and evenly sort the beans. The beans are then dried to reduce moisture to around 8% to ensure quality. Next, they are fed into a dehulling machine, where the soybeans are compressed between two pairs of rollers. This process cracks the soybean hulls and splits the beans into smaller parts. The mixture of soybeans and hulls is then transferred to an air separation system. After dehulling, the soybeans are fed into a screw press machine. Inside the press, the soybeans are moved forward by a screw conveyor inside the pressing tube. The final product is full-fat soy meal. After being processed in the screw press, the soybean meal is transferred to a mechanical oil press. In this press, the product continues to move along the press cage, where it is compressed under pressure. The oil is extracted through the slits in the cage and collected in a container below. At the same time, the remaining oil cake, with an oil content of about 7 to 8% and a temperature range of 120 to 130 degrees Celsius, is produced. The oil cake, which contains a high level of fiber and protein, is widely used in the production of animal feed for livestock and poultry. It helps promote animal growth and improves the quality of meat, milk, and eggs. Thanks to its rich nutritional value, the oil cake becomes an essential component of the diet for many animals, contributing to optimized farming efficiency. After filtering and refining, the oil is sent for quality inspection. Here, quality indicators such as clarity, smell, acidity, and chemical composition are thoroughly checked to ensure the oil meets safety and quality standards before packaging. Compared to other oils like sunflower and olive oil, soybean oil stands out for its low cost and high smoke point, but its higher omega-6 content could lead to nutritional imbalances if consumed excessively. It is transferred to an automated packaging system. The oil is poured into bottles, cans, or flexible packaging according to the required volume. And from here, soybean oil makes its way into kitchens around the world, becoming an essential ingredient in creating delicious and nutritious dishes. From crispy fried foods to fresh, vibrant salads, soybean oil adds a distinct flavor and helps make every meal more satisfying. If India is the mango capital of the world, producing over 50% of the global mango supply, then the United States is the world's largest consumer market for imported mangoes, with a skyrocketing growth rate that has surpassed many other tropical fruit juices like pineapple and guava. Although mango cultivation is expanding in states like Florida and California, domestic production still falls far short of meeting demand. That's why the U.S. spends over $1 billion each year importing mangoes, primarily from Mexico, to satisfy its enormous appetite for this tropical fruit. Mangoes are a guilty pleasure for strict dieters, with a single ripe fruit packing up to 40 grams of sugar, about the same as a can of soda. But for the rest of the world, they're known as tropical gold, sweet, fragrant, and packed with nutrients. And what about you? Are you on team sugar shy, or do you melt at the first taste of juicy, sun-kissed mango? Although technology in the U.S. is highly advanced and mango harvesting robots have begun to emerge, equipped with sensors to detect ripe fruit and robotic arms to pick each mango, this technology is not yet widely adopted. That's because harvesting mangoes isn't easy. The fruit bruises easily and trees are tall with wide canopies. As a result, hand-picking remains the most common method. Even so, machines still play a supporting role, with tools like lifts, conveyors, and creative harvesting devices helping boost efficiency and reduce manual labor. Every April, as mangoes begin to ripen and turn golden under the warm sunlight, the bustling harvest season kicks off. Each mango is carefully inspected right in the field before being picked. Don't be fooled by appearances. Not every golden fruit is ready. Each mango variety has its own ripeness cues. Some turn from green to yellow, others take on a rosy blush, and some can only be judged by gently squeezing the skin to check for just the right firmness. For low-hanging mango trees, harvesting is done entirely by hand. Farmers gently hold each fruit, feeling for ripeness through its taut skin and just right softness. A skill that may seem simple, but actually requires experience to avoid bruising the flesh. When mangoes are out of reach, harvesters use a specialized stem cutting tool, a long pole equipped with a sharp gripping head. This design allows them to reach each mango from the ground and gently cut the stem without causing the fruit to fall or bruise. For taller trees, especially on large-scale farms, hydraulic lifts are used, like a mechanical arm that raises workers safely to reach thick, towering canopies as high as 5 to 6 meters. This blend of traditional techniques and modern support makes mango harvesting more efficient, safer, and less labor-intensive. On average, one person can harvest up to 1,200 mangoes per day, depending on the height of the trees, fruit density, harvesting technique, and weather conditions. Especially when cutting the stem, farmers must leave a small portion attached to the fruit to prevent sap from oozing out and damaging the skin or staining other mangoes. That's why, right after harvest, the stem of each mango is rinsed with a gentle stream of pressurized water to remove the sticky, irritating sap. This simple step not only helps the fruit maintain its fresh appearance, but also extends its shelf life, especially important during long-distance transport or export. Mango sap is highly acidic and can cause skin irritation, burning sensations, or allergic reactions upon direct contact. That's why during harvest season, gloves, arm sleeves, and protective clothing are essential gear for professional mango growers. After harvest, the mangoes are quickly transported to nearby processing facilities to preserve their freshness. The ripe mangoes are placed into large red plastic crates specifically designed with ventilation holes on all sides. These openings help keep the fruit cool and well ventilated, minimizing heat and moisture buildup, and significantly reducing the risk of spoilage during transport. After a bumpy ride aboard heavily loaded trucks, the fresh crates of mangoes finally arrive at the processing facility, where their true transformation begins. Here, workers will conduct a preliminary inspection, carefully selecting the mangoes that meet the required standards, while discarding those that are damaged, bruised, or show signs of disease. Only the finest fruits will proceed to the next stage of the process. Next, the mangoes are placed into a water bath or a continuous flowing water stream, where the gentle sound of water not only helps remove dirt but also cools the fruit, preventing premature fermentation and keeping the mangoes fresh. After the preliminary wash, the mangoes are passed through a high-pressure water spray system, where powerful jets of water clean off any remaining impurities and bacteria from the skin. The spray nozzles are automatically controlled, ensuring that each mango is evenly washed without the need for manual intervention. This not only boosts efficiency, but also reduces the risk of direct contact, all while maintaining the highest quality of the product. The mangoes are soaked once again in a sanitizing water solution, typically ozone water, a method that not only helps eliminate bacteria and mold. Then the mangoes move on to the drying area. Here, they gently roll along a conveyor belt lined with soft, wave-like padding, designed not only to prevent scratches but also to absorb any remaining water on the fruit's surface. Some factories also install overhead air-blowing systems to speed up the drying process, ensuring the mangoes are completely dry before entering the sorting and packaging stages. After being thoroughly washed, the mangoes travel along a conveyor system and pass through a scanner equipped with automatic sensors that sort them based on size, color, and ripeness. Mangoes that meet the standards in shape and show no signs of bruising or damage are sent to the next processing stages, while undersized, substandard, or damaged ones are redirected for processing into other products, depending on specific criteria, such as mango juice or dried mango slices. Mangoes that meet the quality standards after sorting are labeled with traceability information, clearly stating the place of origin and packing date. Each fruit is carefully placed in plastic trays or cardboard boxes lined with soft foam to minimize impact during long-distance transportation. For premium varieties like Honey Gold or Nam Dok Mai, each mango is additionally wrapped in protective mesh to preserve its shape and extend shelf life. The mangoes are then stored in cold rooms at an ideal temperature of 10 to 13 degrees Celsius, with humidity around 90% to maintain their crisp texture and vibrant color. Once all quality standards are met, the mangoes are packed into large cartons and shipped in refrigerated containers to supermarkets, restaurants, and retail chains around the world. And while the highest quality mangoes are carefully packaged for destinations around the world, the remaining ones embark on a different kind of journey, a magical transformation inside modern processing factories, to be transformed into a wide variety of mango-based products. First, let's take a closer look at the frozen mango production line, where ripe, juicy mangoes are flash frozen step by step to preserve the full taste of summer all year round. After sorting, each mango is securely fixed onto a specialized holder. Then, an automated blade system peels off the outer skin with a rotating motion, carefully preserving the fruit's shape and flesh. Next comes the cheek cutting stage, a task that requires both skill and precision. Since mango flesh is soft and easily bruised, most factories still perform this step manually, despite having modern production lines. Then the mangoes are washed again, using a foaming solution and air pressure to remove any remaining dirt, then quickly dried by an automated lifting system before moving on to the next processing stage. After the cheeks are separated and the seed removed, the mangoes are fed into an automatic cutting machine that slices them into uniform cubes. Sharp, high-speed blades process thousands of pieces per minute with high precision, ensuring each cube is the ideal size for freezing. Ever wondered how frozen mango cubes stay loose instead of clumping into a solid block? The secret lies in the vibrating mesh system. As the cubes move along a stainless steel tray, continuous shaking spreads them evenly and removes excess surface moisture. This small step makes a big difference. By minimizing moisture, it prevents ice buildup and keeps the cubes separate. Modern IQF lines can freeze 2 to 3 tons of mango per hour, dropping the temperature to -35°C in under 20 minutes. After freezing, the mangoes are packed into moisture-resistant cardboard boxes lined with plastic film, each weighing about 5 to 10 kilograms. The boxes are sealed, fully labeled, and stacked on pallets, ready to be stored in cold rooms for export. The magic of delicious mangoes doesn't stop there. Mango isn't just turned into crispy snacks, it also drives millions of people crazy for the iconic, chewy dried mango. Once the mango is ready, golden mango slices are gently placed into the drying chamber. Here, they undergo a slow drying process in a tightly controlled environment, typically between 50 and 60 degrees Celsius. The drying period lasts from 10 to 14 hours, depending on the thickness of the slices and the ripeness of the fruit. This process reduces the moisture content to an ideal level while preserving the mango's natural color, sweet flavor, and irresistibly soft, chewy texture. After drying, the soft mango slices are removed from the trays and sealed in foil pouches to extend shelf life. And now, let's head to the mango juice factory, the part we've all been waiting for. Here, workers place mangoes into trays and use hand pressure to pre-press them into small cube-like chunks about 20 millimeters in size, helping to release some of the juice and prepare them for the final pressing process. Next, the mango chunks are fed into a grinding machine. This equipment crushes the small pieces into a fine pulp. The resulting pulp is then transferred to a fruit press where mechanical pressure is applied to squeeze out the juice. To obtain a clear juice, the mixture must go through an additional filtration process to remove any remaining solids. The filtered mango juice is then filled into large industrial plastic drums, lined with specialized plastic bags to prevent contamination and ensure food safety. These drums typically hold between 200 to 250 liters of juice and are kept refrigerated or deep frozen while awaiting transport to bottling facilities. Finally, the mango juice is automatically filled into thoroughly sterilized PET bottles, then sealed tightly using heat sealing technology to prevent air or bacteria from entering. This fully enclosed, highly automated process not only ensures food safety but also extends shelf life, so every drop of juice reaches consumers rich in sweetness, smooth in texture, and full of nutrients. From there, it finds its way everywhere. On the shelves of major supermarkets, in family refrigerators, next to a glass of ice on a summer table, or as part of a refreshing, energizing breakfast. Leaving behind the bustling processing factories, we return to the peaceful, endless mango orchards to explore how mangoes are grown, the true beginning of every miracle. Mango trees are usually grown from young grafted saplings nurtured in nurseries. Once the plant reaches about 40 to 60 centimeters in height and has developed a stable root system, farmers transplant it into prepared planting holes in the field. The soil is carefully packed around the base to retain moisture and support the young tree. From here, the long journey of careful cultivation begins. In the early months, farmers carry out strategic tip pruning, cutting off the main shoot to prevent the tree from growing too tall and encourage lateral branching. As new branches emerge, they are gently tied and guided to help form a low, well-balanced canopy, improving sunlight exposure and resistance to strong winds. Young mango trees require light shading, consistent moisture, and close protection from pests during this delicate stage. Farmers often use drip irrigation systems, which conserve water while delivering steady hydration to the roots. In parallel, they apply regular fertilization, combining organic and mineral nutrients to strengthen root systems, encourage sturdy growth, and maintain lush green foliage. From these small saplings, wide canopies gradually unfold under the warm countryside sun, preparing for the moment they bloom and bear fruit, bringing the signature sweetness of mango season to tables around the world. In Greek mythology, the peach was once hailed as the fruit of the gods, a symbol of beauty, immortality, and all things magical. However, when it comes to deep processing, the United States is the true heavyweight, the place where peaches are elevated into a refined industry, where every canned slice is treated with care, like an edible work of art. Not every peach earns the honor of making it into a can. Only clingstone varieties, known for their firm flesh, resilient texture, and how tightly they cling to the pit, can withstand sterilization temperatures above 100 degrees Celsius, while still maintaining their shape, smoothness, and intense sweetness. In the heart of summer, when sunlight seeps deep into every leaf and the morning breeze still carries the scent of dawn, California's ripe clingstone peaches begin the most important journey of their lives. Harvest season has arrived. Across the endless peach orchards of California, hundreds of workers begin their day at the break of dawn. These peach pickers aren't just strong, they're fast, nimble, and impressively precise. They balance effortlessly on tall ladders, undaunted by heights, their hands moving swiftly, their eyes scanning every branch for the perfect fruit. They don't rely on machines to check ripeness. They trust their hands, calloused by years of experience and the knowledge passed down through generations. Some peaches fall gently with just a touch, others require a perfect twist, and some are better left for tomorrow. Canning peaches hits like summer throwing a party in your mouth. Under the scorching summer sun, wide-brimmed hats, sun-protective scarves, and sunscreen become the essential armor of every peach picker, not just to block the heat, but also to defend against bees and bugs hiding among the leaves. After all, no one wants to finish a long harvest day with a swollen face. A skilled peach picker can harvest about 90 to 140 kilograms a day. That's thousands of hand-selected peaches. Each bin slowly fills with ripe fruit, their golden orange skins kissed with blush red hues, gleaming like summer gemstones. At the orchard's weighing station, a supervisor uses a handheld scanner, usually a barcode or RFID device, to quickly scan the ID tag on each picker's hat or shirt, precisely recording their effort and daily harvest total. Harvesting may end, but it marks the beginning of a race against time. Once picked, peaches must be delivered to the factory within 6 to 12 hours. Any delay, and their signature freshness and crisp texture begin to fade. Every minute counts, because the goal is clear: get the peaches to the factory at their perfect moment. Peach harvesting isn't loud like rice cutting or bustling like orange picking. It's more like a delicate dance between farmers and fruit. It's the moment the entire orchard waits for, when 3 years of care and effort finally come together in each basket of golden, juicy peaches. Under the summer sun, freshly harvested peaches are quickly transported to the collection area where specialized trucks stand ready. These aren't your average trucks. They're specially designed with shock-absorbing padding. This ensures that each peach is well protected from bruising and heat during the entire journey to the processing plant. Because peaches are extremely delicate, prone to softening, bruising, and even fermenting if left out too long, they cannot stay at room temperature for more than 4 to 6 hours. As soon as the peaches arrive at the receiving area, the rapid cooling process begins. They are immediately fed into a hydrocooling system, where cold water is sprayed continuously like a gentle summer rain, quickly reducing the internal temperature of each fruit. Within just 30 to 45 minutes, the core temperature drops to 3 to 4 degrees Celsius. After that, the peaches are typically placed in short-term cold storage. The cold storage room for peaches after chilling is typically maintained at a temperature of around 0 to 2 degrees Celsius, with a relative humidity of 90 to 95%. This temperature is low enough to slow down the ripening process and limit microbial growth. Once all the ideal conditions have been secured, it's time to wake up the peaches from their chilled slumber and give them a proper cleanup before their big transformation. They continue their journey to the washing area. Before washing, the peaches go through a manual pre-sorting line, where skilled workers quickly remove leaves, twigs, and any foreign objects left over from the harvest. Believe it or not, there have even been cases where snakes were found hiding among the peaches, a job that definitely requires both speed and courage. Right after that, the peaches are transferred to an automated washing area, where high-pressure spray nozzles combined with gently rotating drums rinse away dust and soil from the skin without scratching the delicate surface of the fruit. After being thoroughly washed and polished, the glistening peaches are brought to a long manual sorting table, where skilled workers use nimble hands and sharp eyes to swiftly remove any that don't meet the standards. Bruised, misshapen, overripe, or underripe. Only the finest peaches are allowed to continue the journey. Next, the peaches are sent through a state-of-the-art electronic sorting system. Here, each fruit passes under high-speed cameras and precision sensors that capture its size, shape, and surface condition. The data is instantly processed, and the system gently guides each peach into the correct bin based on its designated grade and size. From there, the peaches with standard sizes begin their journey into the canned peach production process. The process begins with selected peaches being fed into an automated cutting machine. Here, precision blades slice the fruit in half and remove the pit even while the skin is still intact. Cutting the peaches before peeling not only saves time, but also helps prevent the fruit from softening due to exposure to high temperatures in later stages. After the peaches are halved by the machine, workers perform a manual inspection to remove any remaining pit that the machine may have missed. Then, the peach halves are transferred into a tank containing sodium hydroxide, NaOH. In this bath, the outer skin reacts gently with the alkali, loosening and detaching easily within 30 to 60 seconds. Once the outer skin has been loosened by the alkaline solution, the peach halves are transferred to a neutralizing rinse containing citric acid or ascorbic acid, vitamin C. This step effectively eliminates any remaining alkali from the surface of the fruit, while also preventing oxidation and preserving the peach's naturally vibrant yellow color before it continues through the next stages of processing. After being soaked in the alkaline solution, the peach halves are passed through a screening system with uniformly sized holes to sort out and remove any pieces that do not meet the required size standards before moving on to the next processing steps. Next, the peaches move through a high-pressure rinsing system, which thoroughly removes the loosened skin and neutralizes any residual alkali to ensure food safety. At this stage, workers use small knives to carefully trim away any remaining bits of skin, ensuring each peach half is thoroughly cleaned. At the same time, slices that are chipped or misshapen are skillfully adjusted, making the final product more uniform and visually appealing. The peach halves are nearly ready for final processing. They are evenly distributed onto separate conveyor lines and prepared for precise slicing. Here, each half is passed through a specialized cutter equipped with 3-blade knives, which divide the fruit into uniformly sized slices. Before being canned, the peach slices pass through an advanced light-based inspection system, which typically uses ultraviolet UV light. Even the smallest defects are detected and removed. This ensures that only the most perfect slices make it to the final canning stage. Workers then take over the task of arranging the peach slices neatly into cans. This manual arrangement helps enhance the visual appeal of the final product and optimizes the space within each can. You thought that was the end? Not quite. There's one final step: preparing the syrup from water and sugar. It may sound simple, but it's absolutely essential. The syrup is heated to around 90 degrees Celsius and adjusted to 14 to 18 degrees Brix, then poured over the peaches to preserve their color, flavor, and extend shelf life. After being filled with syrup, the cans are tightly sealed using high-precision seamers to ensure they are completely airtight and leak-proof. Then comes the sterilization stage. The peach cans are placed into a retort system, consisting of large horizontal heating chambers, where they are cooked at temperatures ranging from 100 degrees Celsius to 121 degrees Celsius for about 10 to 20 minutes. This process effectively eliminates any remaining microorganisms, extends shelf life, and ensures the peach slices retain their natural shape, texture, and vibrant color. And so, after countless steps of care and precision, the peach cans are cooled and stacked into large blocks right in the canning area. From there, they are transported to a large-scale intermediate warehouse, a spacious, well-ventilated facility designed to hold tens of thousands of cans each day. At this stage, the cans are not yet labeled or boxed, allowing flexibility to meet the specific requirements of each export order. When the shipping schedule arrives, the cans are retrieved from storage and sent through an automatic labeling line, where brand names, ingredients, barcodes, and origin information are applied according to the target market. Finally, the labeled cans are packed into cardboard cartons, typically 12 to 24 cans per box, ready for final inspection before being dispatched from the factory. From the factory's cold storage, they travel in containers to supermarkets, restaurants, cafes, and family. Imagine standing in the middle of endless pineapple fields with rows of spiky green crowns shimmering under the sun. Welcome to Costa Rica, the pineapple paradise of Central America, producing over 3 million tons every year. But when it comes to the pineapple processing industry, the true king is the Philippines, home to massive global-scale factories that contribute over 40% of the 5 billion cans of pineapple produced annually. Pineapples have always been called the royalty of fruits, with a crown on top and a suit of spiky armor. But beneath that rough exterior lies juicy golden flesh, bursting with sweetness and a tropical aroma. It's not just delicious. Pineapples are also a superfruit, packed with vitamin C that boosts immunity, brightens skin, and fights inflammation. Compared to many other tropical fruits like bananas or papayas, pineapples take much longer to be ready for harvest. Each one takes around 18 to 24 months to fully mature. That's nearly 2 years for a single fruit. Every April, when ripe pineapples release their sweet aroma under the morning sun and hide their golden nectar behind spiky armor, harvest season kicks into high gear. Timing is everything. Pineapples taste their best when they hit peak ripeness, but that golden moment is fleeting. Harvest them too early, and they won't have developed enough natural sugars. Wait too long, and they become overly soft and too ripe. That's why farmers rely on experience, instinct, and sometimes even a good old-fashioned taste test to pinpoint the perfect time to harvest. Once all the conditions are just right, the harvesting begins. But pineapple picking is not for the faint of heart. Each plant is surrounded by long, razor-sharp leaves, forming a natural, barbed wire fence. To avoid getting cut or scratched, workers must wear full protective gear. Thick gloves, long-sleeved shirts, and in some places, even face shields to guard against the leaves. Each pineapple is carefully cut from its stem to avoid damaging the crown or harming the mother plant. Interestingly, the base of the plant is often left intact because it can grow another pineapple in about a year. A tough little cycle of renewal. These days, advances in technology have completely transformed the way pineapples are harvested. On large farms, specialized harvest vehicles are now equipped with automatic conveyor belts, eliminating the need for workers to haul heavy bags by hand. Instead, all they need to do is snip the fruit and gently place it on the belt, which then transports the pineapples straight into the storage compartment of the vehicle. This tech not only saves time and reduces manual labor, but also minimizes fruit damage and boosts productivity by 3 to 5 times compared to traditional harvesting methods. Loaded trucks filled with fresh pineapples begin their journey from the lush green fields, wrapping up another bustling harvest season. And now comes the most important moment, when the pineapple will transform into countless irresistible products, ready to conquer all tastes and deliver an unforgettable experience. As soon as the trucks arrive at the factory, they're directed to the receiving area, where the first strict inspection begins. Here, pineapples are released into large water tanks for a surprisingly natural quality check. The ripe, sweet ones, with just the right sugar content, float to the surface. Meanwhile, damaged, underripe, or spoiled fruit sinks to the bottom and is immediately removed. It's a simple yet incredibly effective first step in sorting out the best from the rest. Next comes the cleaning stage. Pineapples are moved into an automated washing system that includes rotating tanks, high-pressure spray nozzles, and a mild disinfectant solution. The entire process takes just a few minutes, yet each line can handle up to 10,000 pineapples per hour. That's the output of a large farm in just one morning. Pretty impressive, right? The most beautiful, perfectly round pineapples are carefully selected and sent to the export storage zone. Here, each fruit is coated with a thin layer of edible plant-based wax, which helps retain moisture and gives the pineapple's skin a glossy, irresistible shine. Once the wax dries, workers perform a final manual inspection, sorting the fruit by size, weight, color, and ripeness. Only the perfect candidates are placed into cardboard boxes, each labeled with a QR code for traceability, ready to cross oceans and land in the hands of consumers around the world. Ripe pineapples are carefully peeled, revealing golden flesh fragrant like morning sunshine. The juicy slices are gently pressed, preserving their natural sweetness, subtle tang, and fresh aroma. The final juice is poured into clean, clear bottles, ready to deliver a burst of pure freshness in every sip. And if you're someone who prefers the crisp bite of a chilled pineapple slice over sipping a glass of juice, then what comes next is sure to get you on the edge of your seat. The process of making ready-to-eat pineapple. After initial preparation, the pineapples are sent into an automatic peeling system equipped with ultra-sharp blades and smart sensors. Each fruit is placed into a mold, where the blades adjust precisely to its size, stripping away the tough, spiky skin in just a few seconds. If pineapples had feelings, they might scream in despair as their sturdy armor is torn off in the blink of an eye. At the same time, a hollow drill neatly removes the hard core from the center, leaving behind nothing but the juicy, golden goodness. Moving on to the next step, where golden rings are created without a single human touch, perfectly shaped and astonishingly precise. Moments later, they rest neatly inside gleaming cans, bathed in a sweet syrup, like tropical jewels waiting to be handed over to their lucky recipient. In a separate process, the golden pineapple rings continue their journey along the conveyor belt, where they are neatly cut into uniform triangular pieces. From here, the pineapple is directed into two main processing paths, one for canning, the other for drying. For canned pineapple, each piece is carefully placed into tins, filled with syrup or pineapple juice, then sealed and sent through a sterilization process. Once cooled, the cans are labeled, boxed, and moved to the finished goods warehouse. As for dried pineapple, the pieces are placed into drying chambers until they reach the desired texture. After cooling and sorting, they are packed in specialized packaging to preserve flavor and extend shelf life. After witnessing the impressive transformation of pineapples in the factory, you might wonder, what did those fruits look like before they hit the conveyor belt? And where does their journey begin? Every journey begins with a solid foundation, and for pineapples, that foundation is the soil. But not every plot of land is immediately ready to welcome young shoots. First, the soil must be thoroughly loosened. This step isn't just about turning the top layer. It's a full-scale restoration, a way to awaken the earth after many growing seasons. High-powered tractors are brought in to break up the hardened subsoil, compacted over time by sun, rain, and repeated farming. Once loosened, air, water, and nutrients can flow deep into the ground, creating a fertile, well-prepared foundation for the next planting season. Once the soil is ready, growers move on to selecting the planting material. Healthy, uniform pineapple suckers, free from pests and diseases, typically 2 to 3 months old. At this stage, the suckers are ideal for quick rooting and stable growth. Planting is done by hand or machine, in neat, straight rows. Each sucker is placed upright, with the base firmly in contact with the soil. Spacing is carefully calculated to give each plant enough room to spread its leaves, absorb sunlight, and take in nutrients without competing with its neighbors. Though it's just the starting step, improper planting, such as placing the sucker at an angle, too shallow, or too deep, can hinder root development and slow down growth. Right after planting, the drip irrigation system is activated, delivering water consistently and efficiently. Some farms even use automated fertigation systems, which send dissolved nutrients straight to the roots, tailored to each stage of growth. Before the pineapple can grow vigorously, weed removal is an important step to eliminate competition for space and nutrients. Then, applying urea provides the necessary nitrogen, helping the pineapple quickly develop lush green leaves and grow strong and healthy. Once it has accumulated enough nutrients, the pineapple starts to grow vigorously, preparing to bloom and bear fruit, leading to a promising harvest. The pineapple has matured, but the journey of agriculture is full of exciting possibilities. Not just pineapples, but many other crops are changing every day thanks to technological advancements. How will technology transform the way we farm? Let's talk about lemons. Did you know that these bright, tangy fruits belong to the species Citrus limon? Lemons have a vibrant yellow peel, a mildly sour taste, and a light, refreshing aroma. In the US, lemons are primarily grown in California, Arizona, and Florida, 3 states with warm climates, plenty of sunshine, and fertile soil, making them perfect for cultivating this citrus fruit. Lemons typically take about 6 to 9 months to grow from blossom to harvest. When summer arrives, you can witness the meticulous harvesting process. Skilled farmers carefully handpick each lemon, ensuring that every fruit meets the highest quality standards. It's a delicate and precise task, designed to preserve the freshness and flavor that lemons are known for. Every early morning across the vast lemon orchards in California, when the weather is still cool and refreshing, lemons are carefully picked straight from the branches. Farmers use their hands or simple tools like pruning shears to gently detach the fruit, ensuring the peel remains flawless and undamaged. This process requires meticulous attention to detail, as even the smallest imperfection on the surface can affect the quality and value of the lemon. After being picked, the lemons are carefully placed into soft-lined baskets to prevent bruising or damage. Once the baskets are full, the farmers transfer the lemons into larger containers located at various collection points across the field. These containers are then gathered and prepared for transport to the processing facility. Harvesting lemons entirely by hand not only preserves the natural quality of each fruit, but also reflects the farmer's dedication and meticulous care. From the initial careful handling in the fields to the processing at the factory, every step is taken to ensure that each lemon retains its freshness and signature flavor by the time it reaches the hands of consumers. After the harvest, the containers filled with freshly picked lemons are quickly transported to the collection area at the processing facility. This is where the journey begins, transforming these simple lemons from the fields into high-quality products ready for the market. The process at the facility is carefully designed and highly organized to ensure that each lemon retains its freshness and meets 60-degree rotating spray nozzles are used to ensure the lemons are thoroughly cleaned from every angle. Next, the lemons pass through a system of fixed drying pads placed along the conveyor. These pads, typically made of soft fabric or rubber, gently touch the surface of the lemons as they move along, removing any remaining water from the washing process. This method not only ensures the lemons are dried quickly, but also helps maintain their natural glossy appearance, preparing them for the next stages of. The machinery quickly sorts the lemons into different categories, such as large, medium, and small sizes, or separates those meeting export standards from those better suited for domestic markets. This step is crucial as it saves time and reduces errors compared to manual sorting methods. However, skilled workers still play a vital role in overseeing the process, ensuring that any defective lemons or those with minor flaws are not missed during the automated sorting. After being sorted by machines, the lemons that meet quality standards go through a final inspection by skilled workers. They carefully check each lemon to remove any with blemishes, bruises, or other imperfections that fail to meet the required quality standards. The lemons are then moved to the packaging area, where they are arranged into colorful mesh bags or sturdy cardboard boxes, depending on the requirements of each market. These packages are labeled with detailed product information, including the country of origin, weight, and relevant quality standards. In some modern facilities, the entire packaging and labeling process is fully automated, using advanced machinery to maximize speed and precision. the journey doesn't end there. Lemons that don't meet the strict quality standards for fresh markets are sent to a dedicated processing area. Here, they are transformed into high-value products like lemon liqueur or lemon juice, ensuring that every lemon serves a purpose.